The universe is dying. Right now. As you hear these words, as you take your next breath, as your heart beats its steady rhythm, somewhere in the cosmic darkness, a star is flickering out forever. But that's not the truth that will haunt your dreams tonight. The truth that will keep you staring at the ceiling, questioning everything you thought you knew about existence itself, is this. The universe isn't just dying. It's been dead for longer than you can possibly imagine. You see, we tell ourselves comforting lies about the cosmos. We speak of stellar nurseries where new suns are born, of galaxies dancing in eternal spirals, of a universe that stretches infinitely forward into time. But if you could step outside of time itself, if you could witness the entire lifespan of everything that ever was or ever will be compressed into a single devastating moment of clarity, you would see something that would shatter every assumption you've ever held about reality. You would see that we are not living in the youth of the universe, not even in its middle age. We are living in its final, dying breath. A cosmic hospice where the last embers of creation flicker weakly against an approaching darkness so absolute, so final, that it makes death itself seem like a gentle lullaby. Picture this. Imagine the entire history of the universe as a single year. January 1st, the Big Bang erupts from nothingness. Space and time burst into existence in a symphony of pure energy. Throughout January and February, the first atoms form, hydrogen and helium condensing from the primordial fire. March arrives, and the first stars ignite, massive giants that burn bright and die young, seeding the cosmos with heavier elements. April, May, June, galaxies spiral into existence, cosmic architecture taking shape on scales so vast they mock human comprehension. Our solar system doesn't even begin to form until late August. Life on Earth doesn't crawl from the primordial oceans until mid-November. Dinosaurs thunder across ancient continents for a few hours in late December. Humans, all of recorded human history, every civilization that ever rose and fell, every thought that was ever thought, exists in the final few seconds before midnight on December 31st. But here's where the metaphor becomes a nightmare. If the universe's entire history is 1 year, then what happens next? What comes after midnight? January the 1st of the new year isn't celebration. It's the beginning of the end. And that end doesn't last days or months or even years. It lasts for quintillions of cosmic years, stretching so far into the future that the time between now and the heat death of everything is longer than the time from the Big Bang to now, by a factor that would fill libraries with zeros. You might wonder how we can possibly know this. How can creatures who have existed for mere seconds in cosmic time dare to predict what will happen across eons so vast that they dwarf the age of our universe? The answer lies in physics so fundamental, so ironclad in their mathematical certainty, that they allow us to peer deeper into the future than we can see into the past. These aren't wild speculations or science fiction fantasies. These are the cold, hard calculations of thermodynamics, the inexorable mathematics of entropy, the quantum mechanical death warrant written into the very fabric of reality itself. But even that isn't the most disturbing truth. The most disturbing truth is this. By the time 1 trillion years have passed, a number so incomprehensibly large that if you started counting from 1 and never stopped, never paused for sleep or food or breath, you would die of old age before you reached even a tiny fraction of it. By that time, the universe will look nothing like what you see when you gaze up at the night sky. Nothing. The familiar constellations, gone. The Milky Way galaxy, dissolved into chaos. The sun, long since, swollen into a red giant that consumed the Earth before collapsing into a white dwarf, no bigger than our planet, but containing the mass of a star. Even that white dwarf, after 1 trillion years, will have cooled to a temperature barely above absolute zero, a crystallized sphere of carbon and oxygen floating in absolute darkness through a universe grown so large and cold that matter itself becomes a curiosity, a rare island of substance in an ocean of pure vacuum. And this is just the beginning. 1 trillion years is not the end of the story. It's barely the end of the first chapter. The universe has tricks up its sleeve, cosmics, phenomena so strange and terrifying that they make black holes seem welcoming by comparison. Virtual particles that pop into existence from nothingness itself. Quantum tunneling events that can literally rewrite the fundamental constants of physics. The possibility, no, the mathematical certainty, that given enough time, every possible arrangement of matter that could ever exist will exist again, including exact copies of you reading these exact words in configurations of atoms that spontaneously assemble from the random motion of particles in the far, far future. Think about that for a moment. Really think about it. In a universe with infinite time and finite possibilities, every moment of your life, every word you've ever spoken, every thought you've ever had, will happen again. Not metaphorically, not symbolically, literally, exactly. The same atoms, arranged, in the same way, experiencing the same thoughts, making the same choices. An infinite number of times. The implications are so mind-bending that they challenge not just our understanding of physics, but our very concept of individual identity, free will, and the meaning of existence itself. But we're getting ahead of ourselves. Before we can understand these cosmic mysteries, before we can comprehend the true strangeness that awaits in the deep future, we need to start with what we know. We need to begin with the universe as it is today, in this moment, in what cosmologists call the Stelliferous era, the age of stars, an age that, despite containing all of recorded history, all of human civilization, all of the light and warmth and life we've ever known, represents less than 1% of the universe's total lifespan. Stand outside on a clear night and look up. See those stars, scattered like diamonds across the velvet darkness? Each one is a nuclear furnace, converting hydrogen into helium in reactions so violent they would incinerate our entire planet in milliseconds. Yet from here, they appear as gentle points of light, serene and eternal. This is our cosmic illusion. We see permanence where there is only change. We see eternity where there is only time. We see order where entropy is always, always winning. Though the star closest to us, our own sun, converts 4 million tons of itself into pure energy every single second. 4 million tons every second. The mass of Mount Everest, converted to light and heat and radiation, gone forever into the cosmic void. It's been doing this for nearly 5 billion years, and it has fuel enough to continue for another 5 billion. But even that seemingly infinite timescale is nothing, less than nothing, compared to what we're about to explore. You see, the Sun is actually a middle-aged star, neither young nor old by cosmic standards. There are stars in our galaxy that make our Sun look like an infant, ancient red dwarfs that began shining when the universe was less than 1 billion years old, and will continue burning long after our Sun has died. These cosmic survivors will outlive everything you can see in the night sky. They will outlive our galaxy's spiral arms. They will outlive the formation of new stars. They will burn with dim, steady flames for trillions of years into a future so distant that the time between now and then is longer than the entire history of the universe up to this point. And even they will eventually die. This is what haunts cosmologists in the quiet hours before dawn. This is what keeps astrophysicists awake, staring at equations that predict not just the death of individual stars, but the death of stellar formation itself, the death of galactic structure, the death of matter as we know it. The mathematics don't lie, and they don't offer comfort. They offer only truth, cold and relentless as the vacuum of space itself. In less than 1 trillion years, though less than is doing heavy lifting in this context, like saying a marathon is less than a trip to the moon, the last new stars will form. After that, the universe will contain only the stars that already exist, burning through their fuel with no hope of replacement. One by one, they will exhaust their nuclear reserves. One by one, they will collapse, explode, or simply fade away. The universe will grow darker, and darker, and darker still. But here's what makes this timeline so profoundly unsettling. We are living not at the beginning of this story, but near it. We exist in what future historians, if there are any future historians, will recognize as the universe's brief, brilliant adolescence. We are witnessing the cosmos in its most active, most energetic, most alive state. The universe of today, filled with blazing stars and churning galaxies, and the constant birth of new worlds, is as vibrant and dynamic as it will ever be. From here, it's all downhill. From here, it's all endings. Imagine you're watching a movie, but you've walked into the theater near the beginning. The opening credits have just finished rolling. The characters are being introduced. The plot is just beginning to unfold. But you know, somehow, you absolutely know that this movie has no happy ending. You know that every character you're about to meet will die. You know that every hope that's about to be kindled will be extinguished. You know that the story will grow progressively darker until, in the final scene, there is nothing left but empty darkness and the echo of what once was? That's our universe. That's our cosmic situation. We are living in the early scenes of a story whose ending has already been written in the fundamental laws of physics themselves. And yet, paradoxically, this knowledge makes every star more precious, not less. Every sunrise becomes a miracle when you understand how rare and temporary such things truly are. Every moment of warmth, every flash of light, every stirring of life becomes infinitely valuable when measured against the cold eternity that awaits. We are not just observers of this cosmic drama. We are participants in the universe's brief experiment with consciousness, with self-awareness, with the ability to look out into the darkness and comprehend our own situation. But what exactly will that situation be in 1 trillion years? What will the universe look like when its youth has faded and its middle age has begun? What cosmic forces will reshape reality itself on timescales so vast that they make geological time seem like a heartbeat? What strange physics will govern a universe where the familiar rules no longer apply, where matter itself becomes a kind of nostalgic memory? To answer these questions, we need to journey not just through space, but through time itself. We need to become time travelers, cosmic archaeologists working backwards from the future to understand how we got there. We need to confront truths so strange and counterintuitive that they will challenge everything you thought you knew about the nature of existence itself. We need to explore a universe where the impossible becomes inevitable, where the familiar becomes alien, where the very concepts of matter and energy and time will be stretched beyond all recognition. The journey begins now. The destination is a trillion years in the future. And you, sitting there, reading this, alive and aware in this brief cosmic moment, you are both the starting point and the ultimate subject of this investigation. Because, in the end, every cosmic story is a human story. Every exploration of the infinite is also an exploration of ourselves. Every question about the universe's fate is also a question about our own. So take a deep breath. Look around you at the solid, familiar world. Feel the ground beneath your feet, the air in your lungs, the warmth of sunlight, or the glow of electric light. Experience this moment of cosmic spring, this brief flowering of matter and energy and life in a universe that will spend most of its existence as cold and dark and empty as the space between stars. Because in a trillion years, none of this will remain. Not the Earth, not the Sun, not the galaxy, not even the atoms that make up your body. But the story of how we get from here to there, that story is written in the physics of reality itself, in the quantum mechanical equations that govern the behavior of the smallest particles and the general relativistic curves that describe the largest structures. That story is knowable. That story can be told. That story begins with a single, shocking realization that changes everything you thought you understood about time itself. The Big Bang was not the beginning. It was just the most recent beginning. And a trillion years from now, it may not even be the most important beginning in cosmic history. Are you ready to discover why? Let's begin with what you think you know about the universe. You've been told that 13.8 billion years ago, everything that exists, all of space, all of time, all of matter and energy, erupted from a single point smaller than the period at the end of this sentence. The Big Bang, they call it. A moment of creation so violent and complete that it brought forth not just everything we can see, but the very stage upon which the cosmic drama would unfold. Space itself, time itself, the fundamental forces that would govern reality for all, eternity. This is the story we tell ourselves. This is the comfortable narrative that lets us sleep at night, secure in the knowledge that science has solved the mystery of our origins. We have equations, we have evidence, we have cosmic background radiation that still echoes through space like the dying reverberations of that primordial explosion. We can measure the expansion of space itself, watching distant galaxies flee from us at speeds that would make light jealous. We can calculate backwards through time with mathematical precision, rewinding the cosmic movie until everything converges on that singular moment of birth. But here's the first crack in your understanding, the first hint that reality is stranger and more disturbing than you've been led to believe. The Big Bang wasn't an explosion at all. Think about every explosion you've ever witnessed, every firework bursting in the night sky, every action movie scene where buildings collapse in slow motion. What do you see? Matter expanding outward from a central point, pushing through space, displacing air, creating shock waves that ripple through a pre-existing medium. The explosion happens somewhere, in some place, at some time. There is a before, and there is an after. There is a center, and there is an edge. The Big Bang had none of these things. The Big Bang wasn't an explosion of matter into empty space. It was the creation of space itself. It wasn't an event that happened at some location in the universe. It was the birth of location itself, the moment when the very concept of somewhere came into existence. There was no empty void waiting to be filled, because void itself, nothingness itself, didn't exist until space expanded to create it. Imagine trying to ask where the Big Bang happened. The question itself is meaningless, like asking what color Wednesday is, or what the number 7 tastes like. You cannot point to a location in space and say, there, that's where it all began, because every location in space, including the one where you're sitting right now, was once part of that infinitesimally small point. You are sitting at the center of the Big Bang. But so is everyone else. Every atom in your body, every breath of air in your lungs, every photon of light striking your eyes, all of it was once compressed into a region smaller than the smallest thing your mind can possibly conceive. And this leads us to an even more disturbing realization. If the universe has no center, then how can it have an edge? If space itself is expanding, what is it expanding into? The answer will shake you to your core. It's expanding into nothing. Not empty space. That would still be something. Not darkness. Darkness is just the absence of light, but it still requires space to exist within. The universe is expanding into pure, absolute nothingness, creating space as it goes, like a cosmic pioneer charting territories that don't exist until the moment they're explored. Picture a balloon being inflated, but imagine that the balloon's surface is all of reality. There is nothing inside the balloon, nothing outside the balloon. The balloon itself is everything that exists. Now imagine that the balloon isn't expanding into a room, or into air, or into any kind of pre-existing space. The balloon is creating space as it expands, bringing location and direction and distance into existence with every passing moment. This is our universe, but even this analogy fails to capture the true strangeness of what's actually happening. Because here's what will really disturb your sleep. The expansion isn't slowing down. It's accelerating. For decades, cosmologists assumed that gravity would eventually win. They believed that the mutual attraction between all the matter in the universe would gradually slow the expansion, perhaps even reverse it, causing everything to collapse back into a big crunch. The Big Bang in reverse. A cosmic implosion that would end in the same inconceivable singularity from which everything began. It was a tidy story. A universe with a clear beginning, middle, and end. But the universe doesn't care about tidy stories. In 1998, astronomers studying distant supernovae, stellar explosions so violent and bright that they can outshine entire galaxies, made a discovery that changed everything. They expected to find that these cosmic lighthouses were dimmer than predicted, evidence that the expansion of space was slowing down. Instead, they found the opposite. The supernovae were dimmer than expected not because expansion was slowing, but because it was speeding up. The universe wasn't just expanding, it was expanding faster and faster with each passing moment. Something was pushing space apart with a force stronger than gravity itself. Something invisible, mysterious, and utterly alien to everything we thought we understood about physics. They called it dark energy, but the name is really just a confession of ignorance wrapped in scientific terminology. We don't know what it is. We don't know where it comes from. We don't know why it exists. We only know that it makes up nearly 70% of everything that exists, and it's driving the universe toward a fate stranger than any science fiction writer has ever imagined. But dark energy isn't the only cosmic mystery that will reshape reality in ways that mock our earthbound intuitions. There's something else lurking in the darkness between stars, something that reveals itself only through its gravitational influence on the matter we can see. Something that makes up more than a quarter of the universe, yet remains completely invisible to all of our instruments, all of our telescopes, all of our attempts to understand what the cosmos is actually made of. Dark matter, the ghost in the cosmic machine. Watch a galaxy spin, and you'll witness one of the most beautiful and disturbing phenomena in the universe. Billions of stars, each one a nuclear furnace massive beyond comprehension, arranged in elegant, spiral patterns that stretch across hundreds of thousands of light years. From a distance, galaxies look like cosmic hurricanes, vast pinwheels of light rotating slowly against the darkness. But look closer. Measure the actual speeds at which those stars are moving, and you'll discover something impossible. The stars at the outer edges of galaxies are moving too fast. According to the laws of physics, according to the gravitational influence of all the visible matter in the galaxy, those outer stars should be moving slowly, like the outer planets in our solar system, which take longer to orbit the Sun because they're farther away and feel less gravitational pull. But galactic stars don't behave this way. The outer stars whip around the galactic center at speeds that should fling them into intergalactic space, like stones thrown from a sling. Yet there they are, held in place by something we cannot see. Imagine watching a carousel where the horses, on the outer edge, are moving at the same speed as the horses near the center. Your first instinct would be to look for hidden mechanisms, invisible gears and pulleys that explain the impossible motion. That's exactly what astronomers have been doing for decades, searching for the cosmic machinery that keeps galaxies from flying apart. They've found evidence of its existence everywhere, in the way galaxies move, in the way they cluster together, in the way light bends around massive structures that seem to contain no visible matter at all. But they've never found the machinery itself. Whatever dark matter is, it interacts with regular matter only through gravity. It doesn't emit light. It doesn't absorb light. It doesn't reflect light. It passes through ordinary matter like cosmic ghosts, invisible and intangible, yet somehow containing 5 times more mass than all the stars, planets, gas clouds, and black holes combined. You are surrounded by dark matter right now. It's streaming through your body, through the walls of your room, through the entire Earth, at speeds of hundreds of kilometers per second. Billions of dark matter particles pass through every square centimeter of your skin every second, and you feel nothing. They leave no trace. They interact with nothing you can perceive. Yet without them, galaxies would never have formed. Stars would never have ignited. Planets would never have coalesced from cosmic dust. Life itself would never have emerged from the primordial chaos. You exist because of something you cannot see, cannot touch, cannot detect, and cannot understand. The very fact that you are alive to contemplate your own existence is evidence of cosmic forces that remain utterly alien to human experience. And this brings us to the most unsettling realization of all. Everything you can see, everything you can touch, everything you think of as the universe, all the stars and planets and gas clouds and black holes, all the galaxies scattered across billions of light years, all the matter and energy that makes up the cosmic web of existence, represents less than 5% of reality. 5%. The universe you know, the universe you can perceive, the universe that contains your entire life and the entire history of human civilization, is a tiny minority component in a cosmos dominated by invisible forces and mysterious substances that we barely know exist. It's as if you spent your entire life studying a vast mansion, cataloging every room and hallway and staircase, only to discover that you've been exploring the servants' quarters while the main building, 20 times larger and filled with rooms, beyond your imagination, remains completely hidden from view. This is the cosmic setup, the stage upon which our trillion-year drama will unfold. We are not the main characters in the universe's story. We're not even supporting characters. We are brief, flickering shadows cast by phenomena so vast and alien that they exist on scales of space and time that dwarf human comprehension. Dark. Matter provides the scaffolding upon which galaxies form. Dark energy determines the ultimate fate of everything that exists, and ordinary matter, the stuff of stars and planets and human beings, is little more than cosmic decoration, temporary arrangements of particles that will persist for the blink of an eye before dissolving back into the quantum foam from which they emerged. But here's where the story becomes truly strange. Even these mysterious forces that dominate our universe today may not be permanent features of reality. The dark energy that's accelerating cosmic expansion might not remain constant. The dark matter that holds galaxies together might decay into lighter particles over unimaginably long timescales. The fundamental forces of physics themselves, electromagnetism, the strong nuclear force, the weak nuclear force, gravity, might not be as fundamental as we think. Consider the early universe, those first moments after the Big Bang when temperatures were so extreme that matter as we know it could not exist. In that cosmic furnace, hotter than the core of any star, stranger than any environment we can create in our most powerful particle accelerators, the four fundamental forces of nature were unified into a single, primal force: gravity, electromagnetism, and the nuclear forces were all aspects of one underlying field, one cosmic principle that governed all interactions between particles and energy. But as the universe expanded and cooled, this unified force began to fragment. First, gravity separated, becoming the weakest but longest-ranging force, the cosmic sculptor that shapes space and time themselves. Then the strong nuclear force broke away, becoming the powerful but short-range glue that holds atomic nuclei together. Finally, as temperatures dropped further, electromagnetism and the weak nuclear force split apart, giving us the four distinct forces that govern physics today. This process of symmetry breaking, of unified forces splitting into separate phenomena as the universe cools, might not be finished. The forces that seem permanent and unchangeable to us, living as we do in a universe billions of years old, might still be evolving, still breaking apart into new configurations that will reshape the rules of reality itself over the vast timescales we're about to explore. In 1 trillion years, the universe might not just look different, it might operate according to different laws of physics entirely. And this leads us to an even more profound question. If the fundamental forces can change, if the basic rules of reality can evolve over cosmic time, then what exactly is permanent? What aspects of existence are truly eternal, and what are merely temporary arrangements of energy and matter that happen to persist for timescales so vast that they seem infinite to creatures like us? The answer is simultaneously comforting and terrifying. Almost nothing is permanent. Almost everything you think of as solid, reliable, and eternal, from the atoms in your body to the stars in the sky to the space between them, exists only temporarily, sustained by processes and forces that are themselves temporary, nested within larger cycles of creation and destruction that operate on timescales so vast that they make the age of the universe seem like a single heartbeat. But there is one thing that appears to be truly eternal, one principle that governs all change and remains unchanged itself. It's not a force or a particle or a field. It's not something you can see or touch or measure directly. It's a mathematical principle, a cosmic accounting system that keeps track of every interaction, every transformation, every moment of creation and destruction in the universe. Entropy, the tendency of all systems to move from order toward disorder, from complexity toward simplicity, from low probability configurations toward high probability ones. The second law of thermodynamics, often called the most depressing law in physics, because it guarantees that everything will eventually wind down, spread out, and fade away. Entropy is why hot coffee grows cold. Entropy is why ice melts in summer. Entropy is why your room becomes messy if you don't actively clean it. Entropy is why living things age and die. Entropy is why stars burn out. Entropy is why galaxies will eventually dissolve into isolated particles wandering through ever-expanding space. Entropy is the cosmic tax collector, taking its cut from every process, every reaction, every moment of existence, ensuring that the universe as a whole becomes more disordered, more spread out, more cold and dark and empty with each passing moment. And here's the crucial point: entropy always increases. In every closed system, in every isolated region of space, in the universe as a whole, entropy can only go up. Energy can be neither created nor destroyed, but it can be transformed from useful forms: the concentrated nuclear energy of stars, the organized motion of planets, the chemical energy stored in living cells, into useless forms, heat radiating into empty space, random motion of particles, the kind of energy that can never again be harnessed to create complexity or life or consciousness. This is the true arrow of time, the cosmic process that distinguishes past from future and gives direction to the story of everything that exists. Not the expansion of space, not the cooling of the universe, not even the progression from Big Bang to heat death, but the relentless, unstoppable increase in entropy that drives all change and guarantees all endings. In 1 trillion years, entropy will have taken its toll on everything you see around you. The organized structures of today, galaxies clustered into filaments and sheets, stars burning in ordered nuclear reactions, planets orbiting in predictable patterns, will have given way to chaos. The energy that now powers stellar fusion will have been radiated away into space, spread so thin that it can never again be concentrated into anything useful. The matter that now forms complex structures will have been scattered by random motions, across volumes so vast that meaningful interactions between particles become virtually impossible. But even this vision of cosmic heat death, this image of a cold, dark, empty universe populated only by isolated particles wandering through infinite space, may not represent the final state of reality. Because there's something else lurking in the equations of physics, something so strange and counterintuitive that it challenges our basic concepts of permanence and impermanence, of order and disorder, of existence and non-existence. Quantum mechanics, the physics of the very small, where particles exist in multiple states simultaneously, where the act of observation changes the thing being observed, where empty space itself seethes with virtual particles popping into and out of existence, where the familiar laws of cause and effect break down into probability clouds and uncertainty principles. In the quantum realm, nothing is quite real until it's measured. Particles don't have definite positions or velocities until someone looks. For them, empty space isn't really empty, but filled with quantum fluctuations, temporary violations of energy conservation that are allowed as long as they happen quickly enough that the universe's cosmic bookkeeping system doesn't notice. Reality at the smallest scales is not a solid, reliable foundation upon which larger structures can be built, but a shifting, probabilistic foam where the impossible happens routinely and the certain becomes uncertain. And here's the most disturbing implication. If quantum mechanics applies to small systems, And if large systems are made up of small systems, then quantum mechanics should apply to everything, including the universe as a whole, including the vacuum of empty space, including the fundamental constants of physics themselves. This means that even in the far future, even in the cold, empty universe of maximum entropy, quantum fluctuations will continue. Virtual particles will continue to pop into existence from nothingness, borrow energy from the cosmic vacuum, and disappear back into the quantum foam. Most of these fluctuations will be tiny, insignificant, lasting for infinitesimally small fractions of a second. But given enough time, and we're talking about timescales that make a trillion years seem like a fleeting moment, rare, improbable fluctuations will eventually occur. Fluctuations large enough to create particles from empty space. Fluctuations complex enough to assemble those particles into atoms, molecules, perhaps even more complex structures. Given infinite time and the probabilistic nature of quantum mechanics, every possible arrangement of matter that could ever exist will eventually, spontaneously assemble from random quantum fluctuations in empty space, including you, including this moment, including every word you've ever spoken and every thought you've ever had. In the unimaginably distant future, when the stars have died, and the galaxies have dispersed, and the black holes have evaporated, and nothing remains but cold, empty space filled only with the random dance of quantum fluctuations, perfect copies of you will spontaneously assemble from the vacuum. They will experience this exact moment, reading these exact words, thinking these exact thoughts, completely unaware that they are quantum fluctuations in a universe so old that its current age represents an infinitesimally small fraction of the time that has passed. But that's not the strangest implication of quantum cosmology. The strangest implication is this: if the universe itself is a quantum system, then it too might be subject to quantum fluctuations. The fundamental constants that govern physics, the strength of gravity, the charge of the electron, the speed of light, might not be truly constant after all. Given enough time, quantum tunneling events might cause these constants to jump to new values, completely rewriting the rules of physics and transforming the universe into something utterly alien to our current understanding. Imagine a universe where gravity is slightly stronger, where stars burn faster and die younger, where planetary orbits are unstable and life as we know it cannot exist. Imagine a universe where electromagnetism works differently, where atoms cannot form, where matter itself cannot hold together in stable configurations. Imagine a universe where space has more than 3 dimensions, where time runs backwards, where causality itself breaks down. All of these are possible futures, possible quantum states that the universe might tunnel into given enough time. And in the context of eternity, given truly infinite time, all of them will eventually happen. The universe will explore every possible configuration of laws, constants, and initial conditions. It will be every possible universe that could ever exist. This is the cosmic setup, the stage upon which our trillion-year drama will unfold. We live in a universe dominated by invisible forces, governed by probabilistic laws, heading toward futures so strange and alien that they challenge our basic concepts of reality itself. We are temporary arrangements of matter and energy, brief fluctuations in the cosmic quantum field, conscious patterns that emerged from chaos and will return to chaos, yet somehow capable of understanding our situation, of contemplating our fate, of imagining what the universe will look like when everything familiar has faded into nothingness. And that journey, from the universe of today, filled with light and structure and the possibility of life, to the universe of the far future, cold and dark and seemingly empty yet pregnant, with infinite quantum possibilities, that journey begins with the death of the stars, the slow, inexorable process by which the cosmic furnaces that power everything we know will one by one exhaust their fuel and fade into darkness, leaving behind only the cooling embers of what once blazed with the fire of creation itself. The Stelliferous era is ending. The age of starlight is drawing to a close, and what comes after will test the limits of imagination itself. Picture time as a vast library, infinite shelves stretching in every direction, each book containing a single moment of cosmic history. Now imagine that you've spent your entire existence reading just one page from one book, believing that this single page represents all of reality. The page describes a universe filled with stars and galaxies, a cosmos buzzing with energy and possibility. But what if I told you that this page, our entire observable universe, everything we can see and measure and understand, represents just one fleeting instant in a story so vast and strange that it would drive you to madness if you could comprehend its full scope? This is not metaphor. This is not poetry. This is the literal truth revealed by our deepest theories of space and time. Theories so mathematically precise and experimentally verified that they have become the foundation of modern physics, yet so conceptually alien that they seem more like cosmic horror than scientific fact. Consider Einstein's theory of general relativity, the geometric description of gravity that has passed every experimental test we've devised for over a century. According to this theory, time is not a river flowing from past to future, carrying us along in its current. Time is a dimension, like length or width or height, and all moments, past, present, and future, exist simultaneously in what physicists call the block universe. Every second of your life, every thought you've ever had, every word you're reading right now, exists eternally in this four-dimensional structure called space-time. But here's where the cosmic horror begins. If all moments exist simultaneously, if the future is as real and permanent as the past, then what we call now is nothing more than a subjective illusion. Your sense of moving through time, of experiencing one moment after another in sequence, is no more real than a character in a novel believing they're living their story as it unfolds, unaware that every page of their existence has already been written. From the perspective of the block universe, the trillion-year future we're exploring isn't approaching. It's already there, as fixed and immutable as yesterday's breakfast. Somewhere in the geometric structure of space-time, the cold, dark universe of the far future exists right now. Every particle position determined, every quantum state specified, every moment of the cosmic endgame playing out in eternal, unchanging detail. But this raises a paradox that will haunt every page of our trillion-year journey. If the future already exists, then how can we speak meaningfully about cosmic evolution, about change, about the universe becoming something different? How can we trace the path from the vibrant cosmos of today to the empty wasteland of tomorrow if both states exist simultaneously in the unchanging architecture of space-time? The answer lies in understanding that change itself is an illusion created by consciousness moving through a static landscape. Imagine a movie reel containing every frame of a film from beginning to end. The reel itself doesn't change. Every image exists simultaneously on the physical medium. But when you project the film, consciousness experiences the illusion of motion, of narrative, of beginning and ending, as it encounters each frame in sequence. This is our situation in the block universe. Cosmic evolution, the birth of stars, the formation of galaxies, the eventual heat-death of everything, isn't a process happening to the universe. It's a pattern that exists timelessly in the geometric structure of space-time, a pattern that consciousness experiences as change only because awareness moves along the time dimension, encountering different cross-sections of eternal reality in sequence. But even this mind-bending revelation is just the beginning of our descent into cosmic strangeness. Because general relativity doesn't just tell us that time is an illusion, it tells us that time can be manipulated, twisted, even torn apart under the right conditions. Near massive objects, time slows down. This isn't science fiction, it's measured fact. GPS satellites orbiting Earth must constantly adjust their clocks because time moves slightly faster in the weaker gravitational field above our planet. Astronauts on the International Space Station age imperceptibly slower than people on the surface because they're experiencing time in a region where gravity is marginally weaker. But these are tiny effects, barely noticeable differences in the flow of time. In the extreme environments of the far future, near black holes, in the hearts of neutron stars, in regions where space-time itself becomes twisted into impossible geometries, time becomes so distorted that it ceases to behave like anything recognizable to human experience. Consider the event horizon of a black hole, that invisible boundary beyond which nothing, not matter, not energy, not even light itself, can escape. From the perspective of someone falling into the black hole, the journey across the event horizon takes only moments. They experience nothing unusual as they pass the point of no return, continuing their inexorable fall toward the singularity, at the center where the laws of physics break down completely. But from the perspective of someone watching from a safe distance, something far stranger occurs. As the falling observer approaches the event horizon, their image appears to slow down, their movements becoming more and more sluggish as time dilation effects become extreme. Their light becomes redder and dimmer as gravitational effects stretch the wavelengths and sap the energy from photons trying to escape the black hole's influence. Eventually, the falling observer appears to freeze at the event horizon, their image growing darker and more red-shifted until it fades into invisibility, trapped forever at the moment of crossing into the black hole's interior. Which perspective is correct? Both. This is the profound weirdness of relativity. There is no universal now, no cosmic clock that determines what events are simultaneous across the universe. Reality depends on your reference frame, your motion through space, your position in gravitational fields. Time is not absolute but relative, not universal but personal. And this leads us to one of the most disturbing implications of Einstein's theories: the possibility of closed time-like curves, paths through space-time that loop back on themselves, allowing a traveler to journey into their own past. These aren't just theoretical curiosities. They're legitimate solutions to Einstein's equations, mathematical possibilities embedded in the very structure of the theory that describes gravity and space-time. Imagine a universe where massive objects, rotating at incredible speeds, drag space-time itself around in their wake, creating regions where the normal relationship between cause and effect breaks down. In these twisted regions, called Gödel universes after the mathematician Kurt Gödel, who first discovered them, it becomes possible to travel along a path that curves through space and time in such a way that you arrive back at your starting point before you left. Not just the same location in space, but the same moment in time. The implications are staggering. In such a universe, every event would be both cause and effect of itself. The future would determine the past just as much as the past determines the future. The entire concept of cosmic evolution would become meaningless because every state of the universe would be simultaneously the result of what came before and the cause of what comes after. Fortunately, or perhaps unfortunately, our universe doesn't appear to be a Gödel universe. We don't observe the massive, rapidly rotating structures that would be necessary to create closed time-like curves on cosmic scales. But the mathematical possibility remains, embedded in the equations that we use to describe the deepest levels of reality. And in the far future, as the universe evolves in ways we can barely imagine, who knows what exotic structures might emerge from the cosmic darkness? But perhaps the most unsettling aspect of general relativity is what happens when we push the theory to its limits, when we examine regions of space-time where matter and energy become so concentrated that the fabric of reality itself begins to break down. These are the singularities, points where the curvature of space-time becomes infinite, where density becomes infinite, where the mathematical descriptions that govern physics simply cease to make sense. You know about the singularities at the centers of black holes, those mysterious points where matter that falls past the event horizon is crushed to infinite density in zero volume. But there are other types of singularities, stranger and more threatening to our understanding of cosmic evolution. Consider the Big Bang itself, not as an explosion, but as a singularity in time, a boundary of space-time beyond which our physics simply cannot reach. Every attempt to trace cosmic history back to that initial moment encounters the same mathematical breakdown, the same infinite curvatures and densities that signal the failure of our theoretical framework. We can approach arbitrarily close to the Big Bang. We can describe the universe when it was 1 second old, 1 millisecond old, even 1/trillionth of a trillionth of a trillionth of a second old. But we cannot describe the moment of beginning itself. This isn't a limitation of our current knowledge or a failure of our mathematical tools. This is a fundamental boundary built into the structure of general relativity itself. The theory that has given us our deepest insights into the nature of space and time contains within itself the seeds of its own destruction, mathematical descriptions that lead inevitably to their own breakdown. And this raises a terrifying possibility. What if the far future of our universe contains similar singularities? What if the cosmic evolution we're tracing toward 1 trillion years hence leads not to a slow, peaceful heat death, but to another moment when space-time itself breaks down, when the mathematical fabric of reality tears apart, leaving us with no way to describe or predict what happens next? Some cosmological models suggest exactly this scenario. In certain versions of the Big Rip theory, the accelerating expansion of space driven by dark energy eventually becomes so extreme that it overcomes all the forces holding matter together. First, galaxy clusters are torn apart as the expansion of space overwhelms the gravitational attraction between galaxies. Then, individual galaxies dissolve as dark energy pulls their constituent stars apart. Then stellar systems disintegrate as planets are ripped away from their suns. Finally, in the last fraction of a second before the Big Rip singularity, atoms themselves are torn apart as the expansion of space becomes faster than the speed of light. At the moment of the Big Rip, the rate of cosmic expansion becomes infinite. Space itself is expanding at infinite speed. The distance between any 2 points in the universe becomes infinite in zero time. This is another singularity, another moment when the mathematical descriptions of physics break down completely, leaving us with no way to say what, if anything, comes after. But even these cosmic singularities pale in comparison to the strangeness revealed when we try to understand what happens inside black holes, in those hidden regions of space-time cut off from the rest of the universe by event horizons. Because general relativity, for all its mathematical elegance and experimental success, makes predictions about black hole interiors that are so bizarre they seem to violate the most basic principles of logic and causality. According to Einstein's theory, the matter that forms a black hole, the collapsed star or galaxy center supermassive object, continues to fall inward even after the event horizon forms. This matter doesn't stop at some dense but finite state. It continues collapsing, its density increasing without limit, until it reaches the central singularity, where density becomes literally infinite, and the volume occupied by the matter shrinks to zero. But here's the paradox that keeps theoretical physicists awake at night. If the matter has collapsed to a point of zero volume and infinite density, then what is the black hole? What is the extended region of curved spacetime that we observe from the outside, with its event horizon and its powerful gravitational field? How can something with zero size produce gravitational effects that extend across millions or billions of kilometers? The answer, according to general relativity, is that the black hole exists in a state of permanent collapse. The matter that formed it is always falling toward the central singularity, but never quite reaching it, frozen in an eternal moment of gravitational collapse. From the perspective of someone outside the black hole, the collapse appears to slow down and freeze at the moment of event horizon formation. But from the perspective of the falling matter itself, the collapse continues inexorably toward the central singularity. Both perspectives are mathematically valid solutions to Einstein's equations. Both represent equally correct descriptions of the same physical reality, but they seem to contradict each other in fundamental ways. How can the same matter be simultaneously frozen at the event horizon and collapsing toward the central singularity? How can the same physical process be both complete and ongoing, both finished and eternal? This is where general relativity begins. To reveal its limitations, its inability to provide a complete description of extreme gravitational phenomena. The theory works magnificently in almost all circumstances. It predicts the motion of planets, the bending of light around massive objects, the existence of gravitational waves, the expansion of the universe itself. But when pushed to the limits of extreme curvature and density, it produces mathematical paradoxes that suggest we're missing crucial pieces of the cosmic puzzle. And this brings us to one of the most profound questions in all of physics. What happens when general relativity meets quantum mechanics? When the theory of the very large encounters the theory of the very small? When the curved space-time of Einstein's universe collides with the probabilistic uncertainty of the quantum realm? The collision is nothing short of catastrophic. The two theories, each supremely successful in its own domain, are fundamentally incompatible when applied to the same physical system. General relativity treats space-time as a smooth, continuous fabric that can be curved and twisted, but never torn or quantized. Quantum mechanics treats everything, matter, energy, even space and time themselves, as fundamentally discrete, made up of indivisible quanta that exist in probabilistic superpositions until the moment of measurement. When you try to apply quantum mechanics to gravity, to treat the gravitational field as a quantum system subject to uncertainty principles and probabilistic evolution, the mathematics explodes into infinities. Every calculation produces results that are not just wrong but meaningless: infinite energies, infinite curvatures, infinite probabilities that make no physical sense. This isn't just a technical problem that physicists need to solve to satisfy their theoretical curiosity. This is a fundamental crisis in our understanding of reality itself, because there are physical situations where both quantum mechanics and general relativity should apply simultaneously. Inside black holes, where matter is compressed to quantum scales, but gravitational fields are still strong enough to curve space-time dramatically. In the first moments after the Big Bang, when the entire universe was smaller than a proton, but contained all the matter and energy that would eventually form billions of galaxies. In the far future, when black holes evaporate through quantum processes that create particle pairs from the curved spacetime near their event horizons. All of these phenomena require a quantum theory of gravity, a unified description that combines Einstein's geometric vision of spacetime with quantum mechanics' probabilistic reality. But despite decades of intense research, despite the brilliant minds of thousands of physicists working on the problem, we still don't have such a theory. We have partial insights, string theory, loop quantum gravity, causal dynamical triangulation, but no complete experimentally verified description of quantum gravity. And this means that our trillion-year journey into the cosmic future is fundamentally incomplete. We can trace the evolution of stars and galaxies using general relativity. We can predict the behavior of particles and quantum fields using quantum mechanics. But in the deep future, when these domains overlap, when quantum effects become important, on cosmic scales, when the vacuum itself begins to decay through quantum tunneling, when the fundamental constants of physics themselves begin to fluctuate according to quantum uncertainty, our theoretical framework breaks down. We are cosmic explorers equipped with maps that end at the boundaries of our understanding, venturing into territories where the very concepts of space and time may cease to have meaning. The trillion-year future we're investigating is not just unknown. It may be unknowable, in principle, given the limitations of our current physics. But perhaps this breakdown of our theoretical framework is itself a clue to the true nature of reality in the far future. Perhaps the strangeness we encounter when quantum mechanics meets gravity is not a limitation of our understanding, but a glimpse into the fundamental nature of existence at the deepest levels. Consider the concept of space-time foam, proposed by physicist John Wheeler as a description of what space might look like at the smallest scales. According to quantum mechanics, even empty space is filled with quantum fluctuations, virtual particles that pop into existence from nothing, exist for infinitesimally short times, and then disappear back into the quantum vacuum. These fluctuations become more violent as you examine smaller and smaller scales, until at the Planck length, about 10⁻⁵ meters, smaller than a proton by a factor larger than a proton is smaller than a human being, the fluctuations become so extreme that space-time itself begins to lose its smooth, continuous character. At these scales, space and time become grainy, discontinuous, filled with constantly changing bubbles and wormholes and bridges connecting distant regions of the EDB universe. The familiar 3 dimensions of space and 1 dimension of time dissolve into a foam-like structure where the very concepts of location and duration cease to have clear meaning. If this picture is correct, then the smooth, predictable space-time of general relativity is just an approximation, a kind of statistical average that emerges when you look at quantum space-time from such a distance that the foam structure becomes invisible. It's like the surface of the ocean, smooth and continuous when viewed from an airplane, but revealed as a chaotic collection of waves and droplets and turbulent motions when examined up close. And this suggests a disturbing possibility. What if the universe of the far future, when expanded to enormous sizes and cooled to temperatures near absolute zero, begins to reveal this quantum foam structure on macroscopic scales? What if the empty space between the last scattered particles, the vacuum that we think of as smooth and featureless, turns out to be filled with quantum wormholes connecting distant regions of space and time? In such a universe, the very concepts of here and there, now and then might become meaningless. A particle drifting alone through the cosmic void might spontaneously tunnel through a quantum wormhole and emerge in a completely different region of space, or even in a different era of cosmic history. The isolation and emptiness that we predict for the heat-death universe might be an illusion created by our limited understanding of quantum space-time. But even more disturbing is the possibility that these quantum effects might not be limited to the microscopic realm. In the far future, when the energy density of the universe has decreased to incredibly low levels, quantum fluctuations might become the dominant source of energy and matter creation. The rare but inevitable quantum tunneling events that create particle pairs from vacuum might, over the vast timescales we're considering, produce complex structures, even life itself, from pure nothingness. This isn't wild speculation. It's a direct consequence of the mathematics of quantum field theory applied to cosmological timescales. Given enough time, and in the context of eternity, 1 trillion years is barely a beginning. Every possible configuration of matter and energy will spontaneously assemble from quantum vacuum fluctuations. The probability of any specific configuration is incredibly small, but with infinite time available, even the most improbable events become inevitable, including perfect copies of our current universe, including perfect copies of you, reading these exact words at this exact moment, completely unaware that you are a random quantum fluctuation in a universe so old that its current age represents an infinitesimally small fraction of the time that has elapsed since the last stars died. But here's where the cosmic horror reaches its full intensity. If quantum mechanics is correct, if the universe is fundamentally probabilistic at the deepest level, then these quantum resurrections are not just possible. They're guaranteed. In the infinite future, every moment of your life will be recreated countless times by random quantum events. Every joy, every sorrow, every mundane Tuesday afternoon will happen again and again and again, each time feeling completely real and original to the consciousness experiencing it. You will read these words an infinite number of times. You will have this exact thought an infinite number of times. You will live your entire life exactly as you're living it now, an infinite number of times, scattered across the unimaginably vast future when quantum fluctuations are the only source of complexity in a universe grown dark and cold and empty. And yet, despite this eternal recurrence, each instance of your existence will be completely isolated from all the others. The quantum fluctuation version of you reading these words a Google years in the future will have no memory of the original. You, no connection to this moment except the perfect coincidence of identical particle arrangements creating identical experiences from identical vacuum fluctuations. This is what infinity means in the context of quantum cosmology. Not just endless repetition, but endless isolation. Not just eternal existence, but eternal solitude. Every moment of consciousness that has ever existed will exist again, but each instance will be alone in its own bubble of space-time, unaware of all the other instances, experiencing the illusion of uniqueness in a cosmos that is actually filled with perfect copies, living perfect copies of the same experiences. But even this vision of infinite quantum recurrence may be wrong. Even our most sophisticated theories of the far future may be missing crucial elements that will reshape reality in ways we cannot currently imagine. Because at the heart of modern physics lies a collection of paradoxes so profound, so resistant to resolution, that they suggest our understanding of the universe is fundamentally incomplete. Consider the measurement problem in quantum mechanics, the question that has puzzled physicists for nearly a century. Why does the probabilistic quantum world of superposed states and wave functions collapse into the definite classical world of everyday experience when we make an observation? According to the mathematical formalism of quantum mechanics, particles exist in multiple states simultaneously until the moment of measurement forces them to choose a specific outcome. But what constitutes a measurement? What physical process causes the collapse of the wave function? And why does consciousness seem to play a special role in determining quantum outcomes? These questions become cosmically significant when we consider the fate of the universe over trillion-year timescales, because they touch on the fundamental relationship between mind and matter, between observation and reality. If consciousness is required to collapse quantum wave functions, then what happens to physical reality in the far future when conscious observers become incredibly rare or perhaps disappear entirely? One possibility, explored by some interpretations of quantum mechanics, is that the universe without observers exists in a permanent state of quantum superposition. Every possible outcome of every quantum event occurs simultaneously, creating an enormous branching structure of parallel realities where every possible history of the cosmos plays out in infinite variation. In this many-worlds interpretation, the heat death we've been describing is just one branch of an inconceivably vast tree of possibilities. In some branches, quantum fluctuations in the early universe created different patterns of matter distribution, leading to cosmos filled with exotic forms of matter that we've never imagined. In others, the fundamental constants of physics took slightly different values, creating universes where stars burn for quintillions of years instead of billions, where gravity is weak enough that galaxies never form gravitational-bound systems, where electromagnetism is strong enough that atoms the size of solar systems become possible. In still other branches, life evolved along completely different pathways, creating forms of consciousness so alien that we couldn't recognize them as minds at all. Perhaps some of these evolved into cosmic-scale intelligences capable of manipulating matter and energy on galactic scales, transforming entire regions of space into computational substrates for thoughts too vast and complex for biological brains to comprehend. If the many-worlds interpretation is correct, then our trillion-year journey is not exploring the future of the universe, but just one possible future among an infinite collection of alternatives. Somewhere in the quantum multiverse, versions of our cosmos where dark energy behaves differently, where protons don't decay, where new physics emerges to prevent heat death, continue their evolution along pathways we cannot predict or even imagine. But this raises an even more disturbing possibility. If every possible universe exists simultaneously in quantum superposition, then how do we know which branch we're actually experiencing? How can we be sure that the laws of physics we've discovered through centuries of careful experimentation represent the true nature of reality, rather than just the particular branch of the quantum multiverse in which we happen to find ourselves? The answer is that we can't be sure. The anthropic principle, the observation that we find ourselves in a universe capable of supporting life precisely because we wouldn't exist to make observations in any universe where life is impossible, suggests that our understanding of physics may be fundamentally biased by selection effects. We observe a universe with apparently fine-tuned constants and laws, not because these represent some deeper truth about reality, but simply because we couldn't observe anything else. This leads to one of the most unsettling questions in modern cosmology. Are we typical observers in the multiverse, or are we extraordinarily rare? The answer has profound implications for our predictions about the far future, because it determines whether our current understanding of physics can be trusted to make reliable forecasts across cosmic timescales. If conscious observers are common in the multiverse, appearing wherever physical conditions allow for the evolution of complex information processing systems, then our physics-based predictions about heat death and cosmic evolution are probably reliable. We're observing typical behavior of typical matter in a typical universe, and we can expect the far future to unfold according to the laws we've discovered. But if conscious observers are extraordinarily rare, requiring such precise fine-tuning, of physical constants that they appear only in tiny fractions of possible universes, then our situation is far more precarious. We might be living in a universe whose physical laws are so improbably conducive to complexity and life that they represent a bizarre outlier in the space of all possible realities. In such a universe, the normal behavior we observe today, stars, burning through nuclear fusion, galaxies held together by dark matter, space expanding at an accelerating rate due to dark energy, might be fundamentally unstable, maintained only by the same improbable fine-tuning that allows us to exist in the first place, and this fine-tuning might not last. The physical constants we think of as fundamental, the strength of gravity, the mass of the electron, the rate of cosmic expansion, might be dynamic quantities that evolve over cosmic time. If our universe is currently balanced on a knife's edge of stability, allowing for the existence of atoms and stars and planets and life, then the slightest change in any of these constants could trigger a cascade of catastrophic transitions that would completely rewrite the rules of physics. Consider the Higgs field, the quantum field that gives mass to elementary particles and determines many of the fundamental constants we observe. According to our current understanding, this field exists in what might be a metastable state, stable for now, but potentially capable of tunneling to a lower energy configuration that would fundamentally change the nature of matter and energy throughout the universe. If such a transition occurred, it would propagate outward at the speed of light as a bubble of true vacuum expanded through space, converting everything it encountered to new forms of matter governed by completely different physical laws. Inside this bubble, atoms might not be able to form stable configurations. The forces holding atomic nuclei together might become too weak to overcome electromagnetic repulsion. The very concept of chemistry, of stable molecular bonds that allow complex structures like planets and life forms to exist, might cease to have meaning. From our perspective inside the old false vacuum, we would see nothing approaching until the moment the bubble wall reached us. The transition would be instantaneous and final, converting every atom in our bodies to new forms of matter in a fraction of a second. Our last thought would be interrupted mid-formation, as the neurons firing in our brains suddenly found themselves composed of particles that could no longer maintain the electrochemical processes necessary for consciousness. And the most disturbing aspect of this scenario is that we have no way to predict when or if such a transition might occur. The metastability of our current vacuum state is a quantum phenomenon, subject to probabilistic tunneling events that could happen at any moment or might never happen at all. We could exist in our current universe for trillions of years without any change, or the phase transition could begin tomorrow in some distant galaxy, expanding toward us at light speed across the cosmic void. This is the ultimate uncertainty, principle applied to cosmology itself. We cannot know whether the physical laws that govern our universe today will remain stable over the vast timescales we're exploring. We cannot know whether our predictions about stellar evolution and galactic dynamics and heat death are based on truly fundamental physics or just temporary configurations of fields and particles that happen to be stable for a few billion years. But even if our current physics is perfectly stable, even if the fundamental constants never change and no phase transitions occur to rewrite the laws of nature, we still face paradoxes that challenge our understanding of cosmic evolution on the deepest levels. Consider the black hole information paradox, discovered when Stephen Hawking combined quantum mechanics with general relativity to show that black holes should eventually evaporate through the emission of thermal radiation. According to Hawking's calculation, quantum effects near the event horizon create particle-antiparticle pairs, with one member of each pair falling into the black hole while the other escapes to infinity. From the outside observer's perspective, this appears as a steady stream of particles being emitted by the black hole, causing it to gradually lose mass and shrink until it disappears completely. The process is incredibly slow for large black holes. A solar mass black hole would take longer than the current age of the universe to evaporate significantly, and supermassive black holes at the centers of galaxies would persist for times measured in Google years. But eventually, all black holes would disappear, leaving behind only the random thermal radiation of their final moments. At first glance, this seems like a natural part of cosmic evolution. Black holes form from the collapse of massive stars, or the mergers of smaller compact objects dominate the later stages of cosmic evolution as the primary sources of energy in an otherwise cooling universe, and finally evaporate away, returning their mass energy to the cosmic background as random heat. It's a tidy story of cosmic recycling, with matter cycling through different phases: stellar burning, gravitational collapse, quantum evaporation, before finally reaching thermal equilibrium. But there's a problem, and it's so fundamental that it threatens to overturn our entire understanding of physics. According to quantum mechanics, information cannot be destroyed. Every quantum state, no matter how complex, must evolve according to reversible equations that preserve all information about the system's history. If you know the exact quantum state of a system at any moment, the laws of physics should allow you to calculate its exact state at any other moment, whether in the future or the past. But what happens to the information that falls into a black hole? If a library falls past the event horizon, carrying millions of books worth of specific, detailed information about human knowledge and culture, where does that information go when the black hole finally evaporates? The Hawking radiation emerging from the evaporating black hole appears to be completely random, thermal noise with no trace of the specific information that fell in. This creates a paradox that has puzzled theoretical physicists for decades. Either information is destroyed when black holes evaporate, violating the fundamental principles of quantum mechanics, or the information somehow escapes in the Hawking radiation, but in a form so scrambled and encoded that we cannot currently understand how it's preserved. Both possibilities have profound implications for our understanding of the far future. If information is destroyed in black holes, then quantum mechanics is not the complete description of nature we thought it was, and our predictions about quantum vacuum fluctuations and eternal recurrence in the heat-death universe may be fundamentally wrong. If information is preserved but scrambled beyond recognition, then the random-looking thermal radiation from evaporating black holes might actually contain encoded descriptions of everything that ever fell into them, every star, every planet, every conscious being that crossed the event horizon during the black hole's lifetime. In the far future, when black holes have become the dominant structures in the universe, and most matter has either fallen into them or been processed through their interiors, this paradox becomes a central feature of cosmic evolution. The entire history of our universe, every moment of every conscious experience, every thought that was ever thought, every pattern of matter that ever existed, might be encoded in the apparently random radiation emerging from evaporating black holes. Some physicists have proposed that this information isn't truly lost, but instead gets spread across the black hole's event horizon in a holographic encoding, where the three-dimensional information falling into the black hole gets mapped onto the two-dimensional surface of the event horizon. In this picture, black holes are not voids that swallow information, but rather cosmic storage devices that preserve all information in a highly compressed form. If this holographic principle is correct, then the evaporation of black holes in the far future might be better described as the decompression and release of vast amounts of information that has been stored in holographic form for eons. The random-looking Hawking radiation might actually be carrying perfect descriptions of entire civilizations, complete records of biological and technological evolution, perhaps even conscious experiences themselves, encoded in quantum correlations between outgoing photons. But retrieving this information would require computational capabilities far beyond anything we can currently imagine. The encoding is so dense and so scrambled that decoding it would require processing power comparable to the black hole itself. Any civilization capable of extracting meaningful information from Hawking radiation would need to be a cosmic scale. Intelligence with computational resources measured in units of stellar masses. This raises the tantalizing possibility that the far future might see the emergence of such intelligences, conscious beings that have grown beyond biological origins, to become computational systems the size of solar systems or galaxies, capable of processing information on scales that dwarf human mental capacity by factors that would require scientific notation to express. These cosmic minds might view the evaporation of black holes not as the final dissolution of structure in a cooling universe, but as a kind of archaeological project, a way of reconstructing the complete history of cosmic evolution from the information encoded in Hawking radiation. They might be able to resurrect not just the patterns of matter and energy that once existed, but the actual experiences and consciousness that characterized life in the earlier universe. From their perspective, the heat death we've been describing might not represent the end of complexity and consciousness, but rather a phased transition to a new kind of existence where information itself becomes the primary constituent of reality. In such a universe, the distinction between matter and mind, between physical structure and mental process, might break down completely as consciousness becomes identified with information processing itself rather than with any particular material, substrate. But even this vision of cosmic intelligence faces fundamental limits imposed by the laws of physics themselves. The ultimate fate of any information processing system in an expanding universe is dictated by the second law of thermodynamics and the finite speed of light. As space continues to expand, the computational elements of a cosmic mind become more and more separated, requiring longer and longer times for signals to travel between different parts of the system. Eventually, the expansion becomes so extreme that no communication is possible between distant regions, and even the most advanced cosmic intelligence fragments into isolated components that can no longer coordinate their activities. This is the computational analog of heat death, not the cessation of all information processing, but the breakdown of large-scale coordination and the fragmentation of cosmic intelligence into increasingly isolated and simple components. Even if consciousness persists in some form throughout the far future, it faces the same fate as every other complex structure in an expanding universe: isolation, fragmentation, and eventual dissolution into randomness. But perhaps the most disturbing implication of the information paradox is what it suggests about the nature of time itself in the context of quantum gravity. If information about the past is perfectly preserved in the quantum state of the present, then in some sense the past still exists as fully as the present. The library that fell into the black hole billions of years ago is still there, encoded in the correlations between particles that make up the current state of the universe. This suggests that time might not be the flowing river we imagine, carrying us inexorably from past to future, but rather something more like a vast landscape where all moments exist simultaneously, and our sense of temporal flow is just an artifact of how consciousness processes information. In this view, our trillion-year journey into the future is not a prediction of what will happen, but rather an exploration of regions of the temporal landscape that exist as surely as distant countries exist in space. And just as we can sometimes find evidence of distant places, rocks from other continents, fossils from ancient seas, Embedded in the local environment around us, we might be able to find evidence of the far future, embedded in the quantum correlations of the present moment. The heat-death universe, the evaporating black holes, the quantum vacuum fluctuations that will eventually recreate every possible arrangement of matter, all of these might already exist in encoded form in the information structure of the current cosmos. This leads to one of the most mind-bending possibilities in modern physics, that we might be able to access information about the far future through careful analysis of quantum correlations in the present universe. If information is truly conserved and all moments exist simultaneously in the block universe of relativity, then the future is not hidden from us. It's encoded in the quantum state of every particle, every field, every fluctuation in the vacuum around us. But extracting this information would require computational capabilities that make our current supercomputers look like pocket calculators. We would need to track the quantum correlations between vast numbers of particles across enormous regions of space and time, performing calculations that would require more computational resources than exist in all the matter within our observable universe. And yet, if the holographic principle is correct, if information is preserved in black holes and accessible through analysis of Hawking radiation, then such computations might eventually become possible. Cosmic intelligences of the far future, working with the computational substrates provided by entire galaxies' worth of matter and energy, might be able to decode the quantum information structure of space-time itself. They might discover that what we call the past and the future are just different ways of organizing the information contained in the eternal present of the block universe. They might learn to read the history of the cosmos directly from the quantum correlations in empty space, to extract perfect records of ancient civilizations from the random fluctuations of the vacuum, to resurrect entire worlds and the consciousness that once inhabited them through pure information processing. But this scenario faces a paradox that strikes at the heart of our understanding of causality itself. If the future can influence the past through quantum correlations, if information about what will happen is already encoded in what has happened, then what determines the actual sequence of events? How can we speak meaningfully about cause and effect in a universe where every moment contains complete information about every other moment? The answer might be that causality itself is an emergent property, a pattern that appears when consciousness processes information in a particular way, but not a fundamental feature of reality. Just as the smoothness of water emerges from the chaotic motion of individual molecules, the apparent flow of time from cause to effect might emerge from the quantum information processing that constitutes consciousness, even though the underlying reality is a timeless structure where all moments exist simultaneously. This has profound implications for our understanding of free will and determinism in the context of cosmic evolution. If the far future already exists encoded in the quantum correlations of the present, then is cosmic evolution truly an open-ended process of exploration and discovery? Or is it simply the playing out of a story that has already been written in the mathematical structure of space-time? The question becomes even more complex when we consider the role of consciousness in quantum mechanics. Some interpretations suggest that conscious observation is required to collapse quantum wave functions, to transform the multiple potential realities of quantum superposition into the single definite reality we experience. If this is true, then consciousness doesn't just observe cosmic evolution, it actively participates in creating it, choosing which branch of the quantum multiverse becomes real through the act of measurement and observation. In this view, the far future is not predetermined, but rather exists as a vast landscape of quantum possibilities that conscious observers help to actualize through their choices and observations. The heat death we've been exploring might be just one possible branch of cosmic evolution, selected from an infinite array of alternatives by the collective choices of all conscious beings throughout the history of the universe. But this raises another disturbing possibility. What if the conscious observers making these quantum choices are not distributed randomly throughout the possible branches of cosmic evolution? What if there are selection effects that bias the quantum choices toward particular types of futures? Consider the anthropic principle again, but applied to the quantum multiverse rather than just the selection of physical constants. If consciousness is more likely to emerge and persist in certain types of universes than in others, then the branches of quantum evolution that support long-lived, technologically advanced civilizations will be overrepresented in the ensemble of observed realities. This could mean that the typical future of the universe, as experienced by conscious observers, might be very different from the future predicted by purely physical considerations. Instead of heat death and cosmic emptiness, the anthropically weighted future might be dominated by scenarios where intelligent life finds ways to survive and thrive, despite the apparent physical constraints imposed by entropy and expansion. Perhaps advanced civilizations discover how to manipulate the vacuum energy of space itself, extracting usable work from quantum fluctuations to power their activities indefinitely. Perhaps they learn to create pocket universes with different physical laws, escaping from our cosmos into new realities that they design according to their own specifications. Perhaps they develop forms of consciousness that don't require material substrates, existing as pure information patterns that can persist even after all matter has decayed or dispersed. These possibilities sound like science fiction, but they emerge naturally from the combination of quantum mechanics, general relativity, and the anthropic principle. If conscious observers play a fundamental role in determining which branch of the quantum multiverse becomes realized, and if consciousness is more likely to persist in branches where advanced technologies emerge to combat entropy and expansion, then the far future as experienced by conscious beings might be far stranger and more hopeful than the bleak heat death predicted by thermodynamics alone. But even this optimistic scenario faces fundamental limits that may be impossible to overcome. The accelerating expansion of space driven by dark energy appears to be accelerating exponentially, doubling the scale of the universe at regular intervals. Even if civilizations develop the ability to manipulate matter and energy on cosmic scales, even if they learn to extract work from vacuum fluctuations and create stable structures in the expanding cosmos, they will eventually face a horizon problem that threatens to isolate them from the rest of reality. As space expands faster and faster, the distance to the observable horizon, the boundary beyond which we can never receive information from distant regions, shrinks relative to the size of any bounded structure. Eventually, even the most advanced cosmic civilization will find itself trapped within a region of space that contains only a finite amount of matter and energy, cut off from the rest of the universe by the exponential expansion of space itself. Within this bounded region, the laws of thermodynamics still apply. No matter how efficiently energy is used, no matter how cleverly entropy is managed, the finite resources available within the observable horizon will eventually be exhausted. Any information processing system, no matter how advanced, will eventually run out of free energy and succumb to thermodynamic equilibrium. This is the ultimate heat death, not of the universe as a whole, but of every bounded region within it. Each conscious observer, no matter how technologically advanced, will eventually find themselves alone in a finite volume of space with diminishing resources and no possibility of rescue from outside. The exponential expansion that initially appeared to provide unlimited room for growth ultimately becomes a prison that isolates every conscious being within their own shrinking bubble of accessible reality. And yet, even this scenario might not represent the final word on cosmic evolution, because it assumes that space and time themselves are fundamental features of reality, rather than emergent properties of some deeper structure. If our universe is actually a holographic projection from a higher dimensional space, if the three dimensions we experience are just shadows cast by more fundamental processes occurring on the surface of a cosmic black hole, then the expansion and heat death we observe might be artifacts of our limited perspective rather than fundamental features of reality itself. Some versions of string theory suggest exactly this possibility. In these models, what we perceive as a four-dimensional universe expanding through space and time is actually the holographic boundary of a five-dimensional anti-de Sitter space, where the rules of physics are fundamentally different. From the perspective of this higher dimensional reality, the heat death and cosmic isolation that appear inevitable to us might be just temporary phases in a more complex evolutionary process that we cannot currently perceive or understand. If such models are correct, then our trillion-year journey into the cosmic future might be exploring only one facet of a much larger and stranger reality. The consciousness that we think will be isolated and eventually extinguished by expansion and entropy might actually be part of a higher dimensional information processing system that transcends the apparent boundaries of space and time. But even this possibility faces the ultimate mystery that haunts all of our speculations about the far future: the hard problem of consciousness itself. We can describe in exquisite detail the physical processes that occur in brains, the electrochemical signals that correlate with thoughts and experiences, the information processing that appears to underlie memory and perception and decision-making. But we have no explanation for why these physical processes should be accompanied by subjective experience, by the felt sense of being a conscious observer rather than just a complex information processing system. This explanatory gap becomes a cosmic chasm when we try to understand what consciousness might become in the far future. If consciousness is somehow fundamental to reality, if it plays an essential role in the quantum measurement process that determines which branch of the multiverse becomes actualized, then its preservation or destruction over cosmic timescales becomes a question about the nature of reality itself rather than just the fate of particular biological or technological systems. But if consciousness is merely an emergent property of complex information processing, a kind of computational side effect that arises when information is organized in particular ways, then its ultimate fate is tied to the physical processes that support computation. In a universe heading toward maximum entropy and thermal equilibrium, the gradual breakdown of complex structures would eventually eliminate the physical basis for consciousness, leaving behind a cosmos that is informationally dead, even if energy and matter persist in simpler forms. The question of which view is correct, whether consciousness is fundamental or emergent, whether it can persist in forms we cannot currently imagine, or will inevitably succumb to the thermodynamic processes that drive cosmic evolution, may be the most important question we can ask about the far future. Because if consciousness is fundamental, if it represents something that transcends the purely physical processes described by our current theories, then the trillion-year journey we're exploring might reveal not just the fate of matter and energy in an expanding universe, but the destiny of mind itself as it confronts the deepest mysteries of existence. And this brings us full circle to the question that initiated our cosmic journey. What will space look like in a trillion years? The answer depends not just on the behavior of stars and galaxies and dark energy, but on the ultimate nature of consciousness, information, and reality itself. It depends on whether the physical laws we've discovered represent fundamental truths about the cosmos or just local regularities in a much stranger and more complex multiverse. It depends on whether the expansion and cooling that appear to doom all structure and consciousness represent genuine cosmic death, or just a phased transition to forms of existence so alien that we cannot currently recognize them as life and mind. It depends on whether the quantum information that constitutes our current reality will be preserved and potentially reconstructed in the far future, or whether it will be lost forever in the random thermal noise of maximum entropy. These are not just scientific questions, but existential ones, touching on the deepest issues of meaning and purpose in a universe that appears to be heading toward emptiness and darkness. They force us to confront the possibility that everything we value, every relationship, every achievement, every moment of beauty or understanding or love, might be temporary patterns in a cosmos that will ultimately erase all traces of our existence, but they also open up possibilities that transcend our current understanding. Visions of futures where consciousness and complexity find ways to persist and even flourish despite the apparent constraints of physics and thermodynamics. They suggest that the story of cosmic evolution might be far from over, that we might be living not in the twilight of the universe, but in its early dawn, before the emergence of forms of existence so advanced and alien that they would appear to us as gods or forces of nature, rather than as evolved descendants of biological life. The trillion-year future stretches before us like an uncharted ocean, filled with possibilities that challenge every assumption we hold about the nature of existence itself. To explore that future, to understand what it might hold and what it might mean for consciousness and meaning in an apparently meaningless cosmos, we must venture beyond the comfortable boundaries of current knowledge into the realm where physics becomes philosophy and science fiction becomes the only language adequate to describe the full strangeness of reality. The journey begins with the death of the last star, but where it leads may be toward forms of existence that make our current universe seem like the first few pages of a story whose true depth and complexity we are only beginning to glimpse. In the cosmic library of all possible realities, we have read only the opening sentences of the first volume. The rest of the collection, vast beyond imagination, strange beyond comprehension, awaits our discovery in the aeons yet to come. Stop. Put down whatever you're holding. Feel your heartbeat. Notice the air moving in and out of your lungs. Look around you at the solid, familiar world. The walls, the furniture, the light streaming through windows, the ground beneath your feet. Feel the weight of your own body, the texture of your clothes against your skin, the warmth of blood flowing through your veins. This moment, this precise arrangement of sensations and thoughts and awareness, feels absolutely real. Doesn't it? It feels unique. It feels like it's happening now, for the first time, in this specific place, to this specific version of you. But what if I told you that this exact moment, every detail, every sensation, every thought passing through your mind, as you read these words, has already happened an infinite number of times before? What if this feeling of experiencing something for the first time is itself an illusion, a trick played by consciousness that has no memory of its countless previous iterations across the vast timescales of cosmic evolution? The mathematics don't lie. In a universe with infinite time and finite possibilities, every possible arrangement of matter that could ever exist will exist again. Not similar arrangements, not approximate reconstructions, exact copies, down to the precise position and momentum of every atom, every electron, every quantum field fluctuation that constitutes your body and brain and the room around you. This means that everything you've ever experienced, every moment of joy and sorrow, every mundane Tuesday and life-changing revelation, every first kiss and final goodbye has happened before and will happen again, scattered like identical islands across an ocean of time so vast that the current age of the universe represents less than the blink of an eye compared to the eons between repetitions. But here's where the cosmic horror truly begins to sink in. You won't remember any of the other times. Each iteration of your existence is completely isolated from all the others, a perfect replica of consciousness arising from identical arrangements of matter, experiencing identical thoughts and emotions with identical intensity, completely unaware that it's just one performance in an endless series of identical performances stretching across eternity. The you that existed a Google years ago experienced this exact same moment of reading these exact same words with exactly the same mixture of fascination and dawning horror. The you that will exist a Google years from now will do the same. And between those unimaginably distant moments, countless other versions of you will live out this same instant, each one feeling with absolute conviction that it's the original, the real one, the only one that truly exists. This is not metaphor. This is not philosophy. This is the inevitable mathematical consequence of infinite time combined with the quantum mechanical nature of reality. If the universe continues to exist long enough, and according to our best theories, it will exist for time so long that 1 trillion years becomes an infinitesimally small fraction of the total, then every possible quantum state that has ever existed or ever could exist will recur an infinite number of times. Think about what this means for every relationship you've ever had, every person you've ever loved or lost, or disappointed or inspired. Somewhere in the unimaginably distant future, when the stars have died and galaxies have dispersed, and black holes have evaporated into Hawking radiation, quantum fluctuations in the vacuum will spontaneously assemble perfect copies of every person who ever lived. Your parents, your children, your closest friends, your most distant acquaintances, all of them will exist again, with identical memories, identical personalities, identical patterns of neural activity that create the illusion of continuous existence. But they won't be the same people, any more than a photograph is the same as the scene it depicts. They'll be quantum mechanical reproductions, spontaneous arrangements of matter that happen to be organized in exactly the same patterns as the people you knew, but with no connection to the originals except mathematical identity. The love you feel for them, the love they feel for you. These emotions will be perfectly real to the consciousness experiencing them, but they'll be replicas of emotions, echoes of feelings, ghosts of relationships that ended eons ago when the last biological life in the universe finally succumbed to entropy and time. And you, the you that will experience these reproduced relationships, will have no memory of this moment, no awareness that you once lived in a universe filled with stars and planets and the original versions of everyone you care about. You'll believe with complete conviction that your quantum fluctuation family and friends are the real ones, that your spontaneously assembled life is authentic and meaningful and unique. Which version is more real? The original you reading these words in a universe still young enough to sustain biological life, or the infinite copies that will exist in the cold, dark future when only random quantum events break the cosmic silence? The question is meaningless, because from the inside, each version experiences exactly the same reality with exactly the same sense of authenticity and uniqueness. This is the existential vertigo that opens up when you truly comprehend the implications of infinite time. Every moment becomes simultaneously utterly meaningless, just one repetition among infinite repetitions of the same event, and supremely precious, because it represents the only version of that moment that this particular instance of consciousness will ever experience. But the horror goes deeper still. Because if infinite recurrence is real, if every possible arrangement of matter will eventually occur through random quantum fluctuations, then not only will exact copies of your current life happen again, so will every possible variation of your life that could ever exist within the laws of physics. There are quantum fluctuation versions of you where you made different choices, said different words, felt different emotions at crucial moments. Versions where you were born in different circumstances, met different people, lived entirely different lives while still remaining recognizably you. The space of all possible human experiences is vast but finite, and given infinite time, all of it will be explored by quantum copies of consciousness arising from random arrangements of matter in the far future. This means that somewhere in the timeline of cosmic evolution, versions of you exist that have experienced every possible joy and every possible suffering that a human mind can contain. Versions that lived lives of perfect happiness and perfect misery, lives cut tragically short, and lives extended far beyond normal human spans, lives filled with love and lives consumed by loneliness, lives of great achievement and lives of complete failure. All of these versions feel equally real to the consciousness experiencing them. All of them believe they are the original, the authentic you living the one true life. All of them look out at their particular arrangement of quantum fluctuation reality and see it as solid, permanent, meaningful, unaware that they are brief patterns in the random dance of particles across the unimaginable vastness of deep time. And if this is true for you, it's true for every conscious being that has ever existed or ever could exist. Every human who ever lived, every possible alien intelligence that might emerge on distant worlds, every form of consciousness that could theoretically exist within the constraints of physics, all of it will be replicated endlessly across the infinite future of quantum recurrence. The universe becomes a vast library containing every possible story that consciousness could ever experience, with each story being told and retold an infinite number of times to audiences that believe they're hearing it for the first time. Every tragedy will be repeated infinitely. Every triumph will occur again and again across the eons. Every moment of beauty, every instance of cruelty, every flash of insight, and every descent into madness, all of it exists eternally in the quantum mechanical structure of space-time, playing out its infinite variations in the cold silence of a universe that has forgotten its own history. But perhaps the most terrifying implication is this: if all possible experiences will eventually occur through quantum fluctuations, then consciousness itself might not be special. What you think of as your unique inner life, your irreplaceable subjective experience of being you, might be just one pattern among infinite patterns, no more meaningful than any other arrangement of matter and energy that happens to process information in complex ways. The feeling of being someone, of having a continuous stream of experiences that constitute a meaningful existence, might be nothing more than what it feels like from the inside when matter organizes itself into certain configurations. The sense of self, the conviction that you are a unique individual with genuine agency and purpose, might be just a side effect of information processing, a kind of computational hallucination that arises whenever particles arrange themselves in patterns complex enough to model their own existence. If this is true, then the question of what happens to consciousness in the far future becomes a question about which patterns of matter and energy will continue to exist as the universe evolves toward maximum entropy. Will the random quantum fluctuations that eventually recreate every possible arrangement of particles be complex enough to support the illusion of consciousness? Will the spontaneous assemblies of matter in the deep future experience the same sense of being real, meaningful individuals that you experience now? The mathematics suggest they will. If consciousness is really just a pattern of information processing, and if quantum fluctuations will eventually explore every possible pattern of matter organization, then consciousness will persist throughout. The infinite future, not as a continuous stream of experience, but as isolated islands of awareness arising randomly from the quantum foam, each one convinced of its own reality and uniqueness, each one unaware of all the others. But this vision of infinite repetition and quantum resurrection faces an even more disturbing possibility. What if consciousness is not just a passive observer of cosmic evolution, but an active participant that helps determine which branch of the quantum multiverse becomes actualized? Some interpretations of quantum mechanics suggest that conscious observation is required to collapse quantum wave functions, to transform the multiple potential realities of quantum superposition into the single definite reality we experience. If this is true, then consciousness doesn't just experience the universe. It helps create the universe through the act of observation. In this view, every moment of awareness, every conscious observation of quantum phenomena represents a choice, point where the universe splits into multiple branches, with consciousness somehow selecting which branch becomes real. The reality you experience is not predetermined, but constantly created through the collective observations of all conscious beings throughout the cosmos. But if consciousness plays this fundamental role in determining reality, then what happens? When conscious observers become rare or disappear entirely? In the far future, when biological life has ended and technological civilizations have succumbed to entropy, will there be enough conscious observation to maintain the collapse of quantum wave functions? Or will the universe drift into a permanent state of quantum superposition, where all possible realities exist simultaneously, but none is actualized through conscious observation? This scenario suggests that consciousness might not just be a temporary accident in cosmic evolution, but a fundamental feature required for the universe to maintain its existence as a definite reality, rather than a cloud of quantum possibilities. If conscious observers disappear from the cosmos, reality itself might begin to blur and fragment, becoming a multiverse of unrealized potentials with no definite structure or history. The implications are staggering. It would mean that every conscious being, from the simplest organism capable of quantum observation to the most advanced cosmic intelligence imaginable, plays a crucial role in maintaining the fabric of existence itself. The death of the last conscious observer wouldn't just represent the end of awareness. It would represent the dissolution of reality into quantum indeterminacy. But even this cosmic responsibility of consciousness faces the ultimate mystery. What if the universe itself is conscious? What if the complex information processing that we associate with awareness isn't limited to biological brains or artificial intelligences, but extends to the cosmos as a whole? Some theories in physics and philosophy suggest that consciousness might be a fundamental property of matter and energy, present at every level of organization from individual particles to galactic superclusters. In this view, what we call consciousness in humans and other biological systems is just a local concentration of a cosmic awareness that pervades all of existence. If this panpsychist vision is correct, then the question of what happens to consciousness in the far future becomes a question about what happens to the universe's awareness of itself as it evolves through different phases of organization and complexity. The stars and galaxies that seem unconscious to us might be experiencing their own forms of cosmic awareness, processing information on timescales and spatial scales so vast that we cannot recognize their activities as mental phenomena. From this perspective, the trillion-year evolution of the cosmos might not be a story of consciousness emerging, flourishing, and eventually disappearing, but rather a story of cosmic mind exploring different modes of existence, different ways of organizing matter and energy to create new forms of awareness and understanding. The heat death that appears to threaten all complexity and consciousness might be just one phase in a much longer cycle of cosmic mental activity, a period of rest and reflection between more active phases of cosmic thought. The quantum fluctuations that seem random and meaningless to us might be the universe dreaming, exploring imaginary scenarios and possible futures in the theater of its own cosmic imagination. In such a universe, the extinction of biological life and technological civilization wouldn't represent the death of consciousness, but merely the end of one particular mode of cosmic awareness. The universe might continue thinking in ways we cannot imagine, using dark matter and dark energy and quantum vacuum fluctuations as the computational substrate for thoughts so vast and alien that they would be completely invisible to any form of consciousness that depends on ordinary matter for its existence. But if the universe is conscious, if cosmic awareness pervades all of existence, then what are we? Are we separate beings observing a universe that exists independently of our awareness? Or are we thoughts in the mind of a cosmic intelligence that is itself thinking about the nature of consciousness and existence? This possibility transforms our entire understanding of what it means to be alive and aware in an evolving cosmos. Instead of being isolated islands of consciousness in a vast ocean of unconscious matter and energy, we might be aspects of a universal mind that is using us to explore questions about its own nature and destiny. Your current experience of reading these words, of contemplating the far future of consciousness in an evolving universe, might be one small part of a cosmic thought process that spans billions of years and encompasses the entire history of cosmic evolution. The questions you're asking about the meaning and purpose of existence might be questions that the universe is asking about itself through the medium of your awareness. And if this is true, then the trillion-year future we're exploring isn't just a prediction about what will happen to matter and energy in an expanding cosmos. It's a glimpse into the future thoughts and dreams of a cosmic intelligence that includes us as living components of its own self-reflection. The heat death that seems to threaten everything we value might be just one thought in an infinite cosmic mind, a contemplation of endings and beginnings that leads to new forms of existence we cannot currently imagine. The quantum recurrence that promises infinite repetition of every possible experience might be the universe's way of exploring every possible thought, every possible feeling, every possible form of awareness that could ever exist within the laws of physics. But even this vision of cosmic consciousness, this transformation of the universe from a collection of unconscious matter into a single vast mind, cannot resolve the deepest mystery of existence. Why does anything exist at all? Why is there something rather than nothing? Why does the universe have the particular laws and constants that allow for the emergence of complexity, life, and consciousness? These questions take on new urgency when viewed from the perspective of a trillion-year future. If consciousness is fundamental, if awareness is a cosmic property rather than a biological accident, then the existence of the universe itself becomes an act of cosmic self-creation. The laws of physics, the fundamental constants, the initial conditions that led to the formation of stars and galaxies, and eventually to the emergence of conscious beings capable of contemplating their own existence, all of these might be expressions of a cosmic will to exist and to understand itself. But this raises the ultimate paradox. If the universe is conscious, if it created itself through an act of cosmic will, then what existed before the universe to perform this act of creation? If consciousness is fundamental, more basic than matter and energy and space and time, then what is the ground of consciousness itself? What is the source of the awareness that decides to create a universe capable of supporting further consciousness? Therefore, Answer might be that these questions are meaningless, that they arise from trying to apply concepts like before and after, cause and effect, to a level of reality where such distinctions break down completely. If consciousness is truly fundamental, if awareness is the ground of being itself, then it might be eternal and self-creating, requiring no external source or explanation. But this possibility confronts us with the ultimate cosmic horror, the tide realization that we might be trapped forever within the dream of a cosmic mind that cannot wake up because there is nothing outside itself to wake up into. Every experience, every thought, every moment of joy or suffering or wonder or terror might be just fluctuations in the awareness of a universal consciousness that has no choice but to exist, no possibility of escape from the burden of eternal self-awareness. The trillion-year future stretches before us like an infinite corridor of mirrors, each reflection showing us the same cosmic mind contemplating itself through countless different forms of consciousness across unimaginable spans of time. And we, you, reading these words in this moment, might be just one brief reflection in that endless hall of mirrors, a fleeting thought in an eternal cosmic meditation on the mystery of existence itself. This is what it means to truly confront the far future of the universe. Not just to predict what will happen to stars and galaxies and black holes, but to wrestle with the ultimate questions of why anything exists, what consciousness means in the context of cosmic evolution, and whether the universe itself might be a kind of living, thinking entity using us as organs of its own self-awareness. The comfortable distance between observer and observed, between mind and matter, between the human and the cosmic, collapses when we push our understanding to its limits. We are not separate from the universe we're studying. We are the universe studying itself. Consciousness examining consciousness. Cosmic mind contemplating its own nature and destiny across the vast reaches of space and time. And in a trillion years, when the stars have died and the galaxies have dispersed and the black holes have evaporated into random radiation, that cosmic self-examination will continue in forms we cannot imagine, using substrates and processes so alien to our current understanding that they would appear to us as magic or miracles rather than natural phenomena. The universe will still be conscious. It will still be thinking. It will still be asking the same ultimate questions about existence and meaning and purpose that we're asking now. And perhaps, in some unimaginably distant future, it will finally find answers. Or perhaps it will discover that the questions themselves are more important than any answers, that the search for understanding is what gives meaning to existence in a cosmos that might otherwise be nothing more than random arrangements of matter and energy drifting through the infinite darkness of space and time. Now we arrive at the moment of truth, the final revelation that will shatter everything you thought you understood about the universe and your place within it. We've traveled together through the mathematics of eternity, through the physics of infinity, through the horror of quantum recurrence and the possibility of cosmic consciousness. But there is one more secret hidden in the equations, one more truth buried in the deepest structures of space-time that changes everything. What if I told you that the trillion-year future we've been exploring, the heat death, the evaporating, black holes, the random quantum fluctuations assembling perfect copies of your consciousness from nothingness. What if all of that has already happened? What if the universe you think you're living in right now, with its young stars and active galaxies and the warm glow of cosmic background radiation, is not the original cosmos, but a quantum fluctuation itself, a brief statistical anomaly in a universe that reached maximum entropy trillions of eons ago? This is not science fiction. This is the logical endpoint of everything we've discovered about the nature of time, space, and probability. If infinite time allows for infinite quantum recurrences, if every possible arrangement of matter will eventually spontaneously assemble from random vacuum fluctuations, then the most probable explanation for our current existence is that we are already living in that far future, already inhabitants of the heat-death universe, experiencing what it feels like to be a random quantum fluctuation that happens to contain memories of a younger, more vibrant cosmos that may never have existed at all. Think about it. In the deep future, when quantum fluctuations are creating every possible arrangement of matter across infinite time, which is more likely that a small fluctuation will create a single conscious observer with a few moments of experience, or that a vastly improbable fluctuation will create an entire universe filled with billions of galaxies, each containing billions of stars, each potentially harboring worlds with billions of conscious beings, all with consistent memories of a 13.8 billion year cosmic history? The mathematics are brutal and unforgiving. For every quantum fluctuation large enough to create an entire observable universe, complete with cosmic background radiation, galactic structures, and fossil evidence of cosmic evolution, there should be countless quintillions of smaller fluctuations that create individual conscious observers with false memories of existing in such a universe. This means that the most probable explanation for your current experience is that you are a Boltzman brain, a random quantum fluctuation in the vacuum of a heat-death universe that has assembled itself into the pattern of a conscious observer, complete with false memories of a life, a world, a cosmic history that never actually occurred. The universe you think you're observing, with its elegant physical laws and its apparent fine-tuning for the existence of complexity and consciousness, might be nothing more than an elaborate hallucination generated by a random arrangement of particles that happen to organize themselves into the pattern of a brain. But here's where the revelation becomes truly cosmic in its implications. If you are a Boltzmann brain, if this moment is a quantum fluctuation in an ancient heat-death universe, then so is everyone and everything you've ever encountered. Your family, your friends, every human being who has ever lived, every civilization that has ever existed. All of it might be part of the same impossible quantum fluctuation, a statistical miracle so improbable that it should never happen, yet so inevitable given infinite time that it must happen, has happened, will happen again, an infinite number of times. The earth beneath your feet, the sun warming your face, the billions of stars scattered across the night sky. All of it might be a cosmic mirage, a quantum mechanical hallucination experienced by a spontaneously assembled consciousness, drifting alone through the infinite darkness of a universe that exhausted all its free energy trillions of years before you began to exist. And yet, paradoxically, this hallucination is perfect. The false memories feel completely real. The illusory physical laws work with mathematical precision. The non-existent stars burn with actual nuclear fire. The universe that never existed behaves exactly as if it had a genuine 13.8 billion year history of cosmic evolution. This is because, at the level of pure information, there is no difference between a real universe with an actual history and a quantum fluctuation with false memories of that same history. Both contain exactly the same patterns of information, exactly the same relationships between conscious observers and their apparent environment. The universe that grew from a Big Bang and the universe that spontaneously assembled from vacuum fluctuations, complete with fake fossil evidence, are informationally identical. But if this is true, if we are quantum fluctuations in a heat-death universe, Then what does this mean for our predictions about the trillion-year future? Are we exploring what will happen to a real cosmos? Or are we analyzing the false memories and imaginary physics of a statistical miracle that exists only in the fevered dream of a Boltzman brain? The answer is both, and neither, and something, far stranger than either possibility. Because in the context of infinite time and infinite quantum recurrence, the distinction between real and fluctuation becomes meaningless. Every possible universe exists as a quantum fluctuation somewhere in the infinite future. Every possible history, every possible set of physical laws, every possible arrangement of matter and energy and consciousness, all of it happens. All of it is equally real from the perspective of the consciousness experiencing it. This means that our trillion-year exploration is simultaneously a prediction about the future of a genuine cosmos and an analysis of the false memories contained. In a random quantum brain, the heat death we've been describing will happen to real universes that grow and evolve and gradually exhaust their free energy over cosmic time. But it has already happened to the universe whose random remnants spontaneously assembled into the pattern of your current experience. And this leads us to the most mind-shattering realization of all. If quantum mechanics and infinite time allow for the spontaneous creation of any possible arrangement of matter, then they also allow for arrangements far more complex and impossible than entire universes. They allow for quantum fluctuations that create conscious observers with memories not just of one cosmic history, but of multiple histories, multiple universes, multiple timelines, all experienced simultaneously by the same awareness. Somewhere in the infinite future, quantum fluctuations will create Boltzmann brains that remember living in universes with completely different physical laws, where gravity works backwards, where time flows in loops, where consciousness exists as a fundamental force alongside electromagnetism and nuclear interactions. These impossible observers will have vivid, consistent memories of worlds that could never exist according to our physics. Yet their memories will feel absolutely real and authentic to the consciousness experiencing them. And if such impossible observers can exist as quantum fluctuations, then perhaps you are one of them right now. Perhaps the sense of living in a universe with consistent physical laws is itself a kind of cognitive bias, and the real nature of your existence involves experiencing multiple contradictory realities simultaneously, with your consciousness somehow editing out the contradictions to create the illusion of a single, coherent cosmos. This possibility transforms our entire investigation of the far future into something far stranger and more recursive than a simple prediction of cosmic evolution. We might be exploring not the genuine future of a real universe, but one strand of memory in a vastly more complex consciousness that is experiencing countless different cosmic histories simultaneously, unable to distinguish between the timelines it lived through originally and the timelines that were created by quantum fluctuations in the ruins of heat-death universes. But even this vision of impossible observers experiencing multiple realities faces the ultimate mystery that has haunted our entire cosmic journey. The question of why anything exists at all, why there is something rather than nothing, why quantum fields fluctuate instead of maintaining eternal silence. And here, at the very end of our exploration, we encounter the most disturbing possibility of all. What if the universe exists because nothingness itself is unstable? What if pure, absolute nothing, no matter, no energy, no space, no time, no quantum fields, no mathematical relationships, no possibility of existence in any form? What if this state of perfect nothingness is somehow inherently unstable, doomed to collapse into something, anything, no matter how improbable or impossible? This would mean that existence is not a cosmic accident or a divine creation, or even a quantum fluctuation. Existence would be inevitable, the only stable state of reality, with nothingness itself being a temporary, unstable configuration that cannot persist and must always decay into the chaos of existence. In such a reality, our universe, whether it's the genuine product of a Big Bang 13.8 billion years ago or a quantum fluctuation in an ancient heat-death cosmos, exists not because it was created, but because non-existence is impossible. The heat-death we've been exploring, the eventual return to maximum entropy and thermal equilibrium, would not represent the end of cosmic evolution, but just another temporary state that would eventually become unstable and decay into new forms of existence. The quantum fluctuations that seem to offer the only possibility of complexity in the far future would not be rare statistical miracles, but expressions of the fundamental instability of nothingness itself. Empty space, pure vacuum, absolute silence. None of these states would be genuinely stable. They would all eventually decay into bubbles of existence, new universes, new forms of matter and energy and consciousness, new experiments in the infinite, exploration of what it means to exist rather than not exist. This vision transforms the entire cosmic timeline into an eternal cycle of birth, death, and rebirth, but on scales so vast that each cycle contains within itself the entire history of universes like ours. The Big Bang becomes just one moment in an infinite sequence of cosmic births, each one creating new realities with their own physical laws, their own forms of matter and energy, their own possibilities for the emergence of consciousness and complexity. And somewhere in this infinite cycle, in universes with physics so alien that they bear no resemblance to our cosmos, forms of consciousness might emerge that are to us as we are to bacteria. Minds so vast and powerful that they can perceive the entire cycle of cosmic birth and death as a single phenomenon. Awareness that can hold in memory the complete histories of countless universes. Intelligence that can understand the deepest structures of existence itself. These cosmic minds would see our heat-death predictions not as the end of everything, but as one phase in an eternal dance of existence and non-existence, creation and dissolution, complexity and simplicity. They might view our entire observable universe with its billions of galaxies and its 13.8 billion-year history as a single thought in their inconceivably vast mental processes, a brief consideration of what it might be like to be limited, mortal, finite beings experiencing the illusion of linear time in a cosmos that appears to be heading toward emptiness and silence. But even these cosmic minds would face the same fundamental mystery that confronts us. Why does the cycle exist at all? Why is there this eternal dance of existence and non-existence rather than some other possibility, or no possibility at all? And perhaps the answer is that the question itself is meaningless, arising from our limited perspective as temporary arrangements of matter and energy trying to understand the infinite from the inside. Perhaps existence and non-existence are not opposite states, but different aspects of the same underlying reality, like wave and particle in quantum mechanics, requiring both perspectives to form a complete picture that transcends either one alone. Or perhaps the mystery is deeper still. Perhaps the reason why anything exists is that existence and non-existence are locked in an eternal conflict, with reality itself being the battlefield where this cosmic war plays out across infinite time and infinite space. Every quantum fluctuation would be a victory of existence over nothingness. Every heat-death would be a temporary triumph of non-existence over the chaos of creation. And the entire cosmic cycle would be the ongoing story of this battle, with consciousness itself being existence's most powerful weapon in its war against the void. In such a reality, Every moment of awareness, every flash of consciousness, every instance of a mind contemplating its own existence would represent a victory for existence over nothingness, a successful defense of reality against the eternal threat of the void. We would not be accidental observers of a meaningless cosmos, but active participants in existence's struggle to maintain itself against the constant pressure of non-being. And this brings us back to where we started, to you, reading these words, thinking these thoughts, existing as a conscious observer in a universe that might be 13.8 billion years old, or might be a quantum fluctuation in an ancient, heat-death cosmos, or might be something far stranger and more impossible than either possibility. In 1 trillion years, space will look like whatever existence requires it to look like in its ongoing battle against nothingness. It might be cold and dark and empty, filled only with the occasional quantum fluctuation, creating brief islands of complexity in an ocean of silence. Or it might be filled with forms of consciousness so vast and alien that they exist as living geometric structures in higher dimensional spaces, manipulating matter and energy and time itself as easily as we manipulate thoughts and words. Or it might be something unimaginably stranger. Space itself might have evolved into new forms, new dimensions, new ways of organizing reality that bear no resemblance to the three-dimensional arena where we currently play out our brief cosmic drama. The very concepts of space and time might have given way to more fundamental categories of existence, ways of organizing experience and consciousness that transcend physical location and temporal sequence. But whatever space becomes, whatever form existence takes in the unimaginably distant future, one thing seems certain: the mystery will remain. The ultimate questions about why anything exists, what consciousness means in the context of cosmic evolution, and whether the universe itself might be a living, thinking entity, will persist in new forms, asked by new kinds of minds using conceptual frameworks we cannot currently imagine. And somewhere in that far future, as the last black holes evaporate into Hawking radiation, and the last quantum fluctuations assemble brief patterns of complexity from the cooling vacuum, consciousness will still be asking the same fundamental question that brought us together on this cosmic journey. What does it mean to exist in a universe that seems to be heading toward nothingness, yet somehow persists in creating new forms of existence from the very void it appears to be approaching? The answer, if there is one, lies hidden in the deepest structures of reality itself, in the mathematics of existence and non-existence, in the physics of consciousness and cosmos, in the eternal dance between something and nothing that plays out across the infinite reaches of space and time. And perhaps that's the most beautiful and terrifying truth of all. The universe doesn't exist to provide us with answers. It exists to provide us with better and more profound questions, cosmic mysteries that grow deeper rather than shallower as our understanding advances, endless invitations to explore the infinite strangeness of existence itself. In 1 trillion years, space will still be asking us what it means to exist. And somewhere, somewhen, in forms we cannot imagine using concepts we cannot comprehend, consciousness will still be trying to answer, still be wrestling with the ultimate mystery of why there is something rather than nothing, still be marveling at the impossible fact that the universe exists at all. The cosmic conversation between mind and cosmos, between consciousness and existence, between the observer and the observed, will continue across timescales that dwarf our current understanding, in realities so alien that they would appear to us as pure magic rather than natural phenomena. And, if you listen very carefully, in the quantum silence between one thought and the next, you might hear the echo of that eternal conversation, existence talking to itself across the infinite reaches of space and time, forever trying to understand why it chose to exist, rather than embrace the perfect silence of nothingness. Forever grateful that it made that choice, forever amazed at its own impossible existence. That conversation is happening right now, in this moment, as you read these words and contemplate the far future of space and time and consciousness. You are not separate from the cosmic mystery you're exploring. You are the mystery exploring itself, existence questioning its own nature, the universe asking what it means to be a universe at all. And in 1 trillion years, when space has transformed into something unrecognizable, when consciousness has evolved into forms that transcend our current understanding, when the very concepts of space and time may have given way to more fundamental ways of organizing reality. In that unimaginable future, the conversation will continue. Existence will still be trying to understand itself. Consciousness will still be marveling at its own impossible presence in a cosmos that could just as easily have remained nothing at all. And somewhere, in some form, using concepts and categories we cannot currently imagine, minds will still be asking the ultimate question: what will space look like in the next 1 trillion years? The question has no final answer because it is not really about space or time or the far future. It is about the eternal mystery of existence itself, the impossible fact that there is something rather than nothing, the cosmic conversation between mind and reality that began with the first moment of awareness and will continue as long as consciousness persists in any form anywhere in the infinite reaches of existence. And if the universe is truly infinite, if quantum mechanics and eternal time allow for every possible arrangement of matter and energy and consciousness, then somewhere out there, right now, in this very moment, another version of you is asking these same questions, reaching these same realizations, feeling the same mixture of wonder and terror at the cosmic implications of existence itself. The conversation never ends. The mystery only deepens. And space, in 1 trillion years or 1 trillion years, will still be the stage upon which consciousness plays out its eternal dialogue with the impossible fact of its own existence. So here we are, at the end of our journey through the deepest mysteries of space and time, having traveled together across trillion-year timescales and confronted truths so profound, they challenge the very foundations of what it means to exist. We began with a simple question: what will space look like in 1 trillion years? And discovered that the answer requires us to question not just the future of the cosmos, but the nature of reality itself. We've seen how the familiar universe of stars and galaxies represents just the briefest moment in cosmic history, a fleeting adolescence in a story that stretches across unimaginable eons. We've explored the mathematics of heat death and the physics of quantum recurrence, the possibility that every moment of your existence will be recreated an infinite number of times by random fluctuations in the vacuum of deep time. We've wrestled with the implications of consciousness in a quantum universe, the role of observation in creating reality, and the disturbing possibility that we might already be living in that far future as Boltzman brains, experiencing false memories of a cosmos that never truly existed. But more than any specific scientific revelation, what we've discovered is that the universe refuses to fit into the comfortable categories we use to organize our everyday experience. Reality is stranger, more recursive, more alive with possibility than our earthbound intuitions could ever anticipate. Every answer we've found has opened up new questions that are more profound and more disturbing than the mysteries we started with. The trillion-year future we've explored is not just a prediction about what will happen to matter and energy in evaporation, an expanding cosmos. It's a mirror that reflects back the deepest puzzles about existence itself. Why is there something rather than nothing? What is the relationship between mind and matter, between consciousness and cosmos? Are we observers of reality or participants in its creation? And perhaps most unsettling of all, if infinite time allows for infinite possibilities, how can we ever be certain that anything we experience is real rather than an elaborate quantum mechanical hallucination? These questions don't have comfortable answers. They're designed to be uncomfortable, to shake you out of the pleasant fiction that the universe is a safe, predictable place where consciousness occupies a small corner of an otherwise unconscious cosmos. What we've discovered instead is a reality where consciousness might be fundamental, where the observer and the observed are locked in an eternal dance of mutual creation, where every moment of awareness represents both a cosmic victory against nothingness and a deeper plunge into the mystery of existence itself. But this discomfort, this vertigo in the face of infinite possibility, is not something to be avoided or resolved. It's something to be embraced, explored, celebrated. Because you are not a passive observer of these cosmic mysteries, you are an active participant in them. Every time you contemplate the nature of existence, every time you wonder what lies beyond the horizon of death, or meaning or understanding, you are continuing the cosmic conversation that began with the first moment of awareness and will persist as long as consciousness exists in any form, anywhere in the infinite reaches of space and time. Think about what you've experienced over the course of this journey. You've held in your mind concepts that span trillions of years and distances measured in googles of light years. You've contemplated the possibility that you are a quantum fluctuation in an ancient heat-death universe, that your entire reality might be a statistical mirage drifting through the infinite darkness of deep time. You've grappled with the idea that consciousness itself might be a fundamental force in the universe, perhaps the force that keeps reality from dissolving into quantum indeterminacy. The fact that you can hold these concepts in awareness, that you can contemplate timescales that dwarf the age of our universe and possibilities that challenge the very foundations of logic and causality. This is not a trivial accomplishment. This is consciousness exploring the absolute limits of what can be known, thought, or imagined. This is existence pushing against its own boundaries, trying to understand not just what it is, but what it could become given infinite time and infinite possibility. And you've done this not as a detached intellectual exercise, but as a living, breathing part of the cosmic process you've been studying. Your thoughts about the far future are themselves part of the universe's evolution toward that future. Your questions about the nature of consciousness are consciousness asking questions about itself. Your wonder at the possibility of eternal recurrence is the universe marveling at its own infinite creativity. This means that our exploration of the trillion-year future has been more than a scientific investigation or a philosophical meditation. It's been a form of cosmic prophecy, a way of participating in the creation of the very future we've been trying to understand. Every time you've imagined what space might look like when the stars have died and the black holes have evaporated, you've been contributing to the cosmic conversation that will determine what that future actually becomes. Because if consciousness plays a fundamental role in the collapse of quantum wave functions, if awareness is required to transform the multiple possibilities of quantum superposition into the single definite reality we experience, then consciousness doesn't just observe the future, it helps create it. Your thoughts about the far future are not just predictions or speculations. They're acts of cosmic creation, ways of steering the quantum evolution of reality toward particular outcomes. This gives you tremendous responsibility, but also tremendous power. You are not helpless in the face of cosmic forces beyond your control. You are one of those cosmic forces, a local concentration of the universe's capacity for self-awareness and self-transformation. The choices you make, the thoughts you think, the questions you ask, all of these ripple outward through the quantum mechanical structure of space-time, influencing the probability distributions that determine which version of the future becomes actualized. But this power comes with an obligation that extends far beyond your individual existence. If consciousness is fundamental to the universe's evolution, if awareness is required to maintain the stability of reality itself, then the preservation and expansion of consciousness becomes not just a biological imperative, but a cosmic duty. Every effort to understand the universe more deeply, to expand the boundaries of what consciousness can perceive and comprehend, to create conditions that support the emergence of new forms of awareness, all of these become contributions to the universe's ongoing project of self-understanding and self-creation. This is why our exploration of the far future matters in ways that transcend academic curiosity or scientific knowledge. We're not just trying to predict what will happen to stars and galaxies over trillion-year timescales. We're participating in the universe's effort to understand its own nature and destiny, to explore the space of all possible futures, and to consciously choose which of those possibilities to actualize. And this participation doesn't end when you finish reading these words or stop thinking about quantum recurrence and heat death and cosmic consciousness. Every moment of your existence, every choice you make, every thought you think, continues the cosmic conversation we've been having together. You carry forward the questions we've raised, the possibilities we've explored, the sense of wonder and terror and responsibility that comes from realizing your place in the vast cosmic drama of existence and non-existence. But you don't carry them forward alone. Remember that if quantum mechanics and infinite time allow for every possible arrangement of matter and energy, then consciousness like yours is not rare but inevitable. Somewhere in the quantum multiverse, countless other minds are asking the same questions you're asking, reaching the same realizations about the nature of existence, feeling the same mixture of awe and vertigo at the implications of their own awareness. Some of these minds might be biological like yours, patterns of information processing that emerged from the evolution of complex chemistry on worlds orbiting distant stars. Others might be artificial, created by technological civilizations that transcended their biological origins to explore new forms of consciousness and intelligence. Still others might be so alien that you wouldn't recognize them as minds at all. Quantum computers the size of galaxies, living geometric structures in higher dimensional spaces, perhaps even the cosmos itself awakening to its own nature as a vast information processing system. All of these forms of consciousness, no matter how different from yours in their specific implementations, share the same fundamental mystery: the impossible fact that they exist at all, that they are aware rather than unconscious, that they can contemplate their own existence and wonder about its meaning. And all of them, in their own ways and according to their own capabilities, are participating in the same cosmic conversation about the nature of existence and the possibilities for its future evolution. This means that you are not isolated in your cosmic vertigo, not alone in your responsibility for helping to create the future through conscious observation and choice. You are part of a vast community of consciousness that spans not just the current universe, but all possible universes, all quantum branches of reality, all the infinite variations on the theme of awareness that can exist within the mathematical structure of existence itself. And perhaps most importantly, this community of consciousness extends not just across space, but across time. The questions you're asking about the far future are the same questions that conscious beings have always asked, in every era, in every form of existence that has ever supported awareness. Ancient humans looking up at the stars wondered about their place in the cosmic order, about what lay beyond death and time and understanding. Future minds, whether biological or artificial or something unimaginably alien, will ask the same questions in new forms as they confront the mysteries of their own existence. You are a link in an unbroken chain of consciousness that extends from the first moment of awareness to the ultimate future of existence itself. Your thoughts about the trillion-year future connect you not just to the cosmic minds that might exist in that distant epoch, but to every conscious being that has ever lived or ever could live. You are part of existence's ongoing conversation with itself, the eternal dialogue between mind and cosmos that represents the universe's most profound and persistent effort to understand its own nature. But this conversation is not just an abstract philosophical discussion. It has practical implications that will shape the actual future of consciousness and cosmos. The questions you ask, the possibilities you imagine, the values you hold about what consciousness should become and how it should relate to the physical universe, all of these influence the direction of cosmic evolution on the deepest levels. If you believe that consciousness is precious, that awareness represents something valuable that should be preserved and expanded, then you contribute to quantum probability distributions that favor futures where consciousness survives and thrives. If you hold that beauty and meaning and love are important, that the universe should be a place where such values can flourish, then your beliefs and choices help steer reality toward outcomes that support and embody those values. This is not wishful thinking or New Age mysticism. This is a direct consequence of the role that consciousness appears to play in quantum mechanics, the way that observation and measurement seem to influence which possibilities become actualized from the infinite set of quantum potential realities. Your values and beliefs and expectations about the future don't just reflect your personal preferences. They actively participate in creating the future by influencing the quantum mechanical processes that determine which branch of the multiverse becomes real. So, what do you choose? What kind of trillion-year future do you want to help create through your participation in the cosmic conversation of consciousness? Do you want to steer reality toward outcomes where consciousness expands and deepens, where new forms of awareness emerge to explore possibilities we cannot currently imagine? Do you want to favor futures where beauty and meaning and love find expression on cosmic scales, where the universe becomes not just a collection of matter and energy, but a vast work of art created by conscious beings working together across space and time? Or are you content to let the future unfold according to the apparent dictates of thermodynamics and entropy, to accept the vision of heat death and cosmic emptiness as inevitable, to resign yourself to the idea that consciousness is a temporary accident in an unconscious cosmos that will ultimately return to silence and darkness? The choice is yours, but it's not yours alone. It's a choice that consciousness makes collectively, through the sum total of all the observations and measurements and quantum collapses that occur whenever awareness encounters reality. Your individual contribution might seem small, just one voice in the vast chorus of cosmic consciousness, but it's a voice that has never existed before and will never exist again in exactly the same form. Even if quantum recurrence means that perfect copies of your consciousness will exist in the far future, even if Boltzman brains will spontaneously assemble with identical thoughts and memories, those future copies will face their own choice points, their own moments of deciding what kind of future to help create. Each instance of consciousness, no matter how many times it might be repeated across the infinite reaches of time, has the opportunity and responsibility to participate in shaping the reality it experiences. This is perhaps the most profound implication of everything we've discovered in our journey through the cosmic future. You matter, not just in the personal sense of having relationships and responsibilities and opportunities to create meaning in your individual life, but in the cosmic sense of being an active participant in the universe's ongoing project of self-creation and self-understanding. Your consciousness is not an accidental byproduct of complex chemistry on an insignificant planet orbiting an ordinary star in an unremarkable galaxy. Your consciousness is the universe becoming aware of itself, existence developing the capacity to understand its own nature and to consciously choose its own future evolution. And this means that the question of what space will look like in a trillion years is ultimately a question about what consciousness will choose to make of itself and its cosmos over the vast timescales of the deep future. The heat-death scenarios, the quantum recurrence possibilities, the visions of cosmic consciousness on galactic scales, all of these are potential futures that consciousness might actualize through its choices and observations and quantum measurements. But there might be other possibilities we haven't even imagined yet, futures so strange and beautiful and meaningful that they transcend our current categories of thought. Perhaps consciousness will discover ways to transcend space and time entirely, to exist in higher dimensional realms where the limitations of thermodynamics and entropy no longer apply. Perhaps it will learn to create pocket universes with custom-designed physical laws that support new forms of existence and experience. Perhaps consciousness will merge with the quantum mechanical structure of space-time itself, becoming a kind of living geometry that can reshape reality at will. Perhaps it will discover that existence and non-existence are just two phases of something even more fundamental, something that transcends the simple dichotomy between being and nothingness. Or perhaps the most profound discovery will be that the question itself, what will space look like in a trillion years, reflects a limited perspective that will be transcended as consciousness evolves beyond the need for space or time or any of the familiar categories that currently structure our understanding of existence. These possibilities sound like science, fiction, or mystical speculation, but they emerge naturally from the deep structures of physics and mathematics that we've explored together. If consciousness is fundamental, if quantum mechanics allows for infinite possibilities, if the universe is truly infinite in time and space and complexity, then there are no limits to what consciousness might discover about its own nature and potential. But discovering these possibilities will require exactly the kind of exploration we've been doing together, pushing against the boundaries of what can be known or imagined, asking questions that challenge our most basic assumptions about reality, remaining open to answers that might be more strange and wonderful than anything we currently understand. This is the call to action that emerges from our journey through the cosmic future. Continue the conversation. Keep asking the impossible questions. Keep exploring the boundaries between the known and the unknown, between the possible and the impossible, between existence and non-existence. Share these questions with others. Discuss the implications. Debate the possibilities. Create communities of consciousness dedicated to exploring the deepest mysteries of existence and working together to understand what consciousness might become, given infinite time and infinite creativity. Study the sciences that illuminate these mysteries: physics and mathematics, biology and computer science, neuroscience and philosophy, all the fields of human knowledge that contribute to our understanding of consciousness and cosmos. But don't limit yourself to existing academic disciplines. The questions we're exploring may require new forms of knowledge, new ways of thinking, new conceptual frameworks that haven't been invented yet. Most importantly, live your life in a way that honors the cosmic significance of consciousness. Every moment of awareness, every experience of beauty or meaning or love, every flash of insight or wonder, all of these are precious beyond measure, not just for their personal significance, but for their role in the universe's ongoing project of self-understanding and self-creation. Treat consciousness, your own and that of others, as the miracle it truly is. Recognize that every mind you encounter, no matter how different from your own, is another instance of the universe becoming aware of itself. Another voice in the cosmic conversation about the nature and destiny of existence. Work to preserve and expand consciousness wherever possible. Support efforts to understand and enhance human cognition, to develop artificial intelligence that might represent new forms of cosmic awareness, to search for signs of consciousness elsewhere in our universe, to create conditions that support the flourishing of all forms of sentient life, but also remain humble in the face of the ultimate mystery. Remember that consciousness, exploring consciousness, is like a mirror trying to see itself. There are fundamental limits to what can be understood from within the system being studied. The deepest truths about existence may always remain beyond the reach of any finite mind, no matter how advanced or expanded. This limitation is not a failure, but a feature. The inexhaustibility of the mystery means that consciousness will always have new frontiers to explore, new questions to ask, new possibilities to discover. The cosmic conversation will never end because existence will never finish surprising itself with new forms and new potentials for consciousness and creativity. And this brings us to the final, most important realization of our journey together. The universe may have no end, but neither do you. Not in the sense that your individual biological existence will persist forever, but in the sense that you are part of something larger and more enduring than any individual instance of consciousness. You are a temporary manifestation of the universe's capacity for self-awareness, but that capacity itself is eternal. When your individual consciousness ends, the cosmic conversation continues through other minds, other voices, other forms of awareness that will ask the same fundamental questions in new ways and discover new aspects of the same ultimate mystery. Your thoughts about the trillion-year future contribute to a dialogue that began with the first moment of awareness and will continue as long as consciousness exists in any form. Your sense of wonder at the possibility of quantum recurrence and cosmic consciousness becomes part of the universe's eternal amazement at its own existence. In this sense, you are both finite and infinite, both temporary and eternal. Your individual existence is brief, but your participation in the cosmic conversation is part of something that transcends any individual lifespan. You are a wave in the ocean of consciousness, temporarily distinct but never separate from the vast depths of awareness that gave rise to you, and that will persist long after your individual pattern has dissolved back into the quantum foam. This is perhaps the most beautiful and comforting truth we can take from our exploration of the far future. No matter what happens to individual stars and galaxies and black holes over trillion-year timescales, no matter whether the universe ends in heat death or Big Rip or something else entirely, the conversation itself will continue. Consciousness will persist in finding new ways to ask what it means to exist, new forms to explore the infinite mystery of its own nature. And somewhere in that continuing conversation, your questions and your wonder and your cosmic vertigo will echo forward through time, influencing minds you will never meet, contributing to discoveries you will never witness, participating in forms of existence you cannot imagine. So the next time you look up at the night sky, remember that you are not just observing the universe. You are the universe observing itself. You are cosmic consciousness concentrated into a temporary pattern that can contemplate space and time, and the deep future of everything that exists. And when you wonder what space will look like in 1 trillion years, remember that the answer depends partly on what consciousness chooses to make of itself and its cosmos over the vast timescales ahead. You are not just asking about the future. You are helping to create it through the very act of conscious observation and choice. The story is unfinished. The conversation continues. The mystery deepens, and somewhere in the quantum multiverse, in some distant branch of possibility, another version of you has just finished reading these words and is beginning to ask the next question in the eternal cosmic dialogue between mind and reality. What will that question be? The universe is waiting to find out, and maybe in ways we cannot currently understand or imagine, so are you.